there are really two types of stories that get told. There is this is the tech company that nobody's ever heard of story, and you should, and that's the most common. And then there's the China basically has copied the machine and it's all over, right? So it's this kind of coin flip where it's, the biggest monopoly you've never heard of, and then it's all over. And I do think that's not the story that we want to tell. I think we're looking for something, not just appreciating the complexity of this business, but also understanding that this is more than just a technology play. I think that understates it. The technology is amazing. The technology is super complicated, but it's not just a technology story.
I agree. It's not just a technology story, but if we think of the challenges, especially when we talk about defense and national security today, we have similar, overwhelmingly difficult problems to solve. And the ASML example is a case where seemingly impossible tasks were tackled head on, and then against all odds, people succeed. And all of a sudden we're in a situation where this seemingly impossible endeavor of having the EUV used in the lithography, it's both a technological marvel as well as a core element of national security of the entire world, especially the entire Western Alliance.
So, listeners, this month's category leader is arguably the most important monopoly in the world. And let's be clear, this is a monopoly, but it's a different type of monopoly, and we'll explain more as we get into it. This is a company that is as far from a household name as you could get, yet their technology and their persistence enables our modern lives. So welcome to Category Leaders, the podcast where we unpack the story, the playbook, the principles, and the powers of category leading companies based in Europe, best in the world. I am Colin Brown.
And I'm Martti Wallin, and we are your hosts today when we are unpacking ASML, or Advanced Semiconductor Materials Lithography, as they were originally called. ASML is the most valuable company in Europe and arguably one of the most important companies in the world. Market cap is 400 billion euros. ASML is by far the youngest company that we've covered in category leaders. We started with Baillie Gifford, originally established 1907, Airbus, Zeiss, and now ASML, which was established in 1984. And if the other company won their category, growth stage investing, civil aviation, optics and measurement, then ASML is the category in itself. They are the monopoly with basically every advanced chip on the planet passing through their lithography processes.
And again, I think with that simple statement, we start diving into this rabbit hole. We've talked to employees of this company. We've talked to former employees of this company. Martti and I have done a ton of research. We talked to their competitors, and the rabbit hole just got deeper and deeper. And Martti, I'm super curious to see what you found out. And I hope throughout this episode, I've got a few surprises for you as well. But for my framing, this episode, we're covering it in 5 acts. We have Act 1. I think we need to talk about the forces and the industry in semiconductors. You don't understand ASML if you don't actually understand the semiconductor industry. We need to talk in Act 2 about Philips, the founding of ASMI, the people, its capital, and its multiple near-death experiences. In Act 3, I think it makes sense to talk about how Moore's law slows and the crisis in the industry. Act 4, and you'll hear this phrase a lot, I think we talk about the village of the semiconductor industry and how the village commits and how the 3 musketeers ride to the rescue. And in last stage, Act 5, I think we need to explain the breakthrough that ASML pioneered and how they moved from being part of the industry to almost the infrastructure for the industry and broke those very boom and bust cycles. And then last but not least, and this is a new segment in the podcast, I think we'll need to add in principles of greatness, right? So how does ASML compare against a framework? And Martti and I are going to use our analytical muscles to really test this company. And we're utilizing the frameworks that Jim Collins pioneered in his books Good to Great, Built to Last, and How the Mighty Fall. And then ultimately, and stay with us, we're going to try and land this with the quintessence, the secret hiding in plain sight about this extremely complicated and super important company. So Martti, does that 5-part analysis plus quintessence, does that make sense?
Oh, yes, it does. 100%. And we are not just telling the ASML story, which is complicated enough in itself. We are also telling some of the core story of semiconductors industry. And we are taking on a marathon, listeners, but do stick with us. I think you will find this very interesting and worth your time. And there are some lessons to be learned for any high technology industries in trying to become the category leaders in the future as well.
Okay, fantastic. Right, let's dive in. So, Act 1, before ASML. So, set the clock. We're back to the 1950s and then moving into the 1980s, and not as far back as we've gone with other episodes. So, before ASML exists, before the Netherlands lithography machines that cost hundreds of millions, before these insane mirrors that we talked about in the Zeiss episode that are polished flatter than the surface of the Earth, we need to understand something, I think, a bit more fundamental. Industries don't have a perfect structure. They oscillate. They breathe in, they breathe out. At certain moments in history, vertical integration makes perfect sense. Everything is pulled inside one organization. You have design, you have manufacturing, you have tooling, you have learning. You control the stack because at that point in time, coordination is the hardest problem. At other points, horizontal wins. The specialization that comes from being one player in the stack, not the stack. And you see the forces act on industries. They break apart into modules, suppliers, ecosystems, because no one single organization can keep up with the pace of change. And again, industries don't have a perfect structure. There is no steady state. They're the tides of vertical integration and horizontal specialization. And the semiconductor industry, I think, Martti, is one of the clearest examples of this oscillation forwards and backwards that we've seen.
Yeah, I mean, this is clearly a very important frame because most people talk about industry structure as if it were a destination, a quest for finding the optimal model, rather than a response to pressure. And one of the things I think clearly is that there's not even an optimal model for a specific stage in industry. Sometimes when you're stuck, I mean, when you have the industrial equivalent of writer's block, you just need to shake something, and then getting new people involved, shifting the roles of different structures and parts of the organization may just, let's say, open that block and you get forward. And of course, technology is especially in the very beginning is young and messy. Vertical integration kind of makes sense. You want to get control of all the critical steps. You need very tight and rapid feedback loops. You need control, at least that's the way you feel. You need coherence between product and processes. But when the technology matures, components become standardized, interfaces stabilize, skills spread, and suddenly the pressure flips. The industry wants to disintegrate. But once again, this is one way to see it. It's not the only way, and we can find in industry various ways how they have been integrating and disintegrating their processes. Well, in any case, this back and forth happens again and again. Different industries, different decades, same underlying forces. And what is, of course, very, very specific about semiconductors is that the cycle has been extremely fast. And it's been brutal, pretty much more brutal than almost any other industry in history when we think about the changes that we've seen during the last couple of decades only.
Absolutely. And again, I think, to see why, we have to go back. We have to go back to the early 1960s. The most powerful technology organizations on earth were not Microsoft and Google and Amazon and Meta. They were vertically integrated giants like IBM, Bell Labs, which was inside AT&T, which was itself a massive monopoly, Texas Instruments. And to describe them as companies is kind of a misnomer. I love Steve Ballmer from Microsoft, one of the early employees / co-founder. He described as the sun, the moon, and the stars. When Microsoft was just a speck in the 1970s. These aren't just companies. These are self-contained technological worlds. IBM was the hardware, was the software, was everything. And Bell Labs alone, they produced the transistor, information theory, lasers, solar cells. They have thousands of scientists. They have more Nobel Prize winners than you can shake a stick at. And again, it's not an exaggeration to say that modern electronics is born inside Bell Labs. That's where it comes from. And again, IBM doesn't just build computers. It is the operating system. It's the storage. It's the mainframe. It's the sales forces. It's the training programs. It's the blue suits and white shirts. It is everything. And even the mental models of how corporations use data is IBM. So if you were alive in the 1950s and the early 1960s, and someone asked you who would push computing forward, you would never have said an ecosystem. That word would not have crossed your lips. You would have said, one of these giants will do it. Yeah. And for a very long time, you would have been completely right.
Yeah, and I mean, my professor from the University of Technology, who was also the chairman of the computing center of the Helsinki University of Technology, he said that there's only one thing that you can guarantee representing the present and the future. There will be a computer manufactured by IBM, and the programming language Fortran will operate in it. And this was the truth. I mean, this was the only truth when everything else around you is changing. That was used when I was studying. Of course, today we don't have IBM computers that much, but Fortran is still going strong. So some of these things are holding, but that was partly due to the fact that the problems were containable. The technology is hard, but it was not yet fractured across dozens of disciplines. Learning loops were expensive, but they fit inside one organization. And mistakes, whenever they happened, they were painful, but they were survivable. And that's the environment where the infamous Moore's law emerged. And it's important to be precise here. Moore's law is not a law of physics. It was an observation and essentially a law after the fact.
Yeah, it's like one of these kind of has become a thing in its own right. But let's also be clear. In 1965, Gordon Moore, who was then at Fairchild Semiconductor, which is kind of the company before Intel, he publishes a short paper observing that the number of transistors on an integrated circuit is doubling roughly every 2 years. Now, in 1965, let's just be clear, there are about 60 odd transistors on the chip. 60. Yeah? Not billions, which is what we have today, not millions, not tens, just 60. This is a Moore's law is kind of taken a life of its own. But in the day, it was just an observation. Every 2 years, we seem to be able to double the number of transistors on the chip. And the implication isn't speed. It's the fact that the sector, the industry, this emerging semiconductor industry, that gives its name to Silicon Valley, silicon chips, it's learning. And Moore is essentially saying this industry is learning faster than it's hitting its physical limits. And for decades, generations of kind of nameless scientists and researchers and industry practitioners, they kind of take on this baton, they take on this challenge, and the observation continues to hold because of a lot of hard work from a lot of clever people. And not because physics is generous, but because these organizations are improving relentlessly.
Yeah, and this is the critical link. Moore's law survives as long as the industry structure can absorb complexity. And there's even a second Moore's law, which says that the capital investment to this technology is increasing exponentially. And it also then tells the story that, I mean, in order to stay on the bandwagon of Moore's law, it is not easy. So to survive in early decades, vertical integration was the answer. The knowledge requirements were high. Processes were tightly coupled. You needed engineers, manufacturing, and experimentation living together. And that's why semiconductor companies built their own factories, or fabs, short for fabrication plants. And fab is not just a building. It's an ecosystem of concrete concrete and steel. It's a place where silicon wafers are processed through hundreds of steps, lithography, etching, deposition, among others, to turn raw materials into functioning chips. These facilities cost billions, take years to build, and are customized to specific process technologies, and are homes for very, very highly skilled and motivated people. The competence required to maintain these is not something that comes automatically, as we will hear later today. The competence is the core of everything, in addition of having a lot of money and the latest technologies. The owning a fab means owning your destiny, but also your risk.
There is a lovely quote, which is real men have fabs, which is attributed to this point in time. I kind of want to put it on a t-shirt, right?
Yeah.
It's kind of like real men have abs. And the irony is that the AMD CEO that said this very quickly got out of the fab business. So clearly something about masculinity going forward. But for a long time, and again, we're still in the 90s and 60s at this point, that risk is worth taking for the industry, right? Being vertically integrated, owning everything, producing it yourself in San Francisco, in Silicon Valley, where you live. Lithography, it's a difficult word to say, so we'll probably trip over it a couple of times on this podcast, is the process of printing circuit patterns onto silicon using light. It's a difficult process, but in the 1950s and 60s, it's manageable. And by the 1970s, just bringing the clock further forward towards the founding of ASML in the 80s, the masters of that craft are Japanese companies like Canon and Nikon. They bring decades of optical expertise, mechanical precision, and manufacturing discipline to the table. So if you're running a fab, if you're a real man running a fab in Silicon Valley, your lithography tools actually at this point come from Japan. Yeah. So that again is an interesting part. It's vertically integrated, but your tools come from someone else. And that's not a weakness in the semiconductor system. That is the system. And the industry's found a stable point in the oscillation at this stage. In the 50s, 60s, and 70s, we're doubling every 2 years. The cost of these fabs are going up, but the number of transistors is also increasing on the chip. So we're building bigger buildings to build smaller chips. But at this stage, it's working.
Yeah, but the tides never stop moving. And why? Why is this? It's the unquenched thirst of your customers of wanting more. They want more, they want better, and at the same time, they want affordable, because everybody understands that the end user customers, which mostly are consumers, they are not going to be buying if the prices rise uncontrollably. The transistor sizes shrink further from microns toward fractions of a micron. The nature of the problem changes again. Lithography stops being just precision engineering and becomes a confrontation with physics itself. Diffraction limits, wavelength constraints, atomic scale imperfections, and the number of disciplines involved explodes. You get into plasma physics, you get to the extreme optics, material science, ultra-precision mechanics, control systems, software, supply chains, and shorter wavelengths. So, even if we were talking about light, it's questionable, are we talking about light when we get to the shorter and shorter wavelengths? But the challenge clearly is that no single company is best in the world of all these. Canon, for example, tried to develop everything by themselves and did not succeed in the best possible way. And all of a sudden they find that vertical integration, which was once a strength, becomes a liability.
I know, listeners, we've spent a little bit of time getting to this point, but to understand ASML, you really need to understand the industry. And at this point in time, the economics turn brutal. We go from every fab costing tens of millions. Then they cost hundreds of millions. This is the 1970s and 80s. This is a lot of money. Yeah. And then by the early 80s, we're approaching billions on the spend out to basically equip your fabrication plant. This is a lot of money. And a wrong bet doesn't just mean delay. It means almost the extinction of your company. The stakes are insanely high because everybody's chasing the more. And at this point, the industry structure comes under real strain. And again, not because leaders are foolish, because engineers lack imagination. That's not the problem. The risk has become too concentrated.
Yeah, and I mean, the other thing is exactly what happened with Airbus. I mean, once we had these aviation companies that were able to do everything in-house, Airbus is not doing everything in-house. They are not doing manufacturing, they are not doing design, they are not doing development all in-house. It's the same thing, and there are two critical resources. The number one is money that you were saying, but also people. You don't have an endless source of individual people who are qualified and who are motivated. You need to, in order to win this game, you need to work together with various organizations in various countries. And this was the point where the oscillation began to swing. The pressure to disintegrate increased, to share risk, to specialize, to coordinate rather than control. And this is where Europe quietly, sneakily, cunningly enters the frame, and not as a semiconductor superpower, but as something very different. A continent exceptionally good at deep specialization in optics, metrology, precision machinery. Europe wasn't the fastest, and it wasn't the dominant one, but it was deep. It was genuinely capable, skilled, and motivated, and this depth becomes decisive when physics try to take over and conquer you.
I think you've said that really well. By the early 90s, Moore's law holds just, and the industry's under real strain. Those real men with fabs, they are struggling. And the old model is no longer sufficient. And unfortunately, the new model doesn't yet exist. And this is the moment when industries don't know what they're becoming, only they know that what they have at the moment just doesn't work. And we're going to plant the seed here, put the little flag in. This is when a village becomes necessary. And Martti and I, when we were discussing this episode, we felt that this is the village concept, that it takes a village. But the villagers don't assemble themselves. Someone has to step forward and go on the impossible mission to save the village. This is like the hero, anonymous in the crowd, stepping forward into the circle of the campfire and saying, I will go on this mad quest to save the village. And if I do that, and if I survive, and if I come back, then we will still have a village. And that someone does not come from Silicon Valley. They don't have an American accent. They don't even have a Japanese accent. They come from the Netherlands, and they come from inside Philips. And this is where ASML begins. So we've kind of set up the industry, but we now need to take a little bit of a segue in Act 2 to the Netherlands itself. And we need to go back in time a little bit to the 1890s. We love going back in history on this podcast.
Exactly.
And we need to talk, before we talk about Philips and before we talk about ASMI, which is the precursor to ASML, we need to talk about the Netherlands itself. Now, it's a country I know particularly well. I am not Dutch, but in 2019, I cycled the length of this country with my kids on the way to the Lego office. So I spent a lot of time in the Netherlands, going north, being the sea on the left. And therefore, the Netherlands itself does speak to me because the country is as flat as a pancake and they produce some very good pancakes. And the country is basically below sea level. And roughly a quarter of the Netherlands exists only because it's continuously engineered to stay in existence. If you cycle across the Netherlands, you see dikes, dams, pumping systems, sluices. These aren't monuments. This is the operating system of this land. If they did not have this, they would basically be underwater, not figuratively, but literally. They would be very, very damp indeed. So engineering is part of the Dutch DNA, because if they didn't have engineering, they would not have a country, and that failure would be catastrophic. So it's not heroic, it's a systems-led engineering culture that has been built over generations, hundreds and hundreds of years. And again, it's quite funny. If you travel to parts of the UK, Somerset Levels, etc., it's Dutch engineers that made that possible. It's the Dutch engineering pride that basically allowed large parts of the world to stay above water.
Yeah. And there's a second layer to this thing when we talk about the Netherlands. The Netherlands, as a small country, used to be, and still is, a very small domestic market. And historically, Dutch companies survived only by going out to the world, and which they definitely did, meeting with customers wherever the customers are, adapting to their needs, and earning trust through reliability. This produces a particular commercial instinct. Get close to the customer, see how the system actually behaves, fix what breaks, try to be part of a solution rather than becoming a part of the problem. That's the thing that is still very, very valid today. And this combination, systems engineering plus customer proximity, understanding true customer needs, is rare, and this will quietly shape everything ASML becomes.
And if listeners haven't heard our previous podcast, getting close to the customer is one of our personal hobby horses. If you won't get into a conversation with either Martti or myself outside these podcasts where we don't talk about get close to the customer.
Yeah.
This isn't something that happened last week in Silicon Valley. This is something that has been happening for many, many years by the best entrepreneurs and businesses of all time. But that hobby horse will continue to get ridden, certainly on this podcast. So we've set up the Netherlands as an engineering and customer obsessed land. Now let's talk about a brand that was very big in the time, slightly gone into the shadows recently, but that is of Philips. So Philips is founded in Eindhoven in 1891, and originally they make light bulbs. And that origin story for Philips actually matters because we see light bulbs today as a kind of consumer novelty, LEDs, very nice. It's kind of faded into the background. We don't think about light bulbs, but light bulbs in the 80s were super important. Yeah, they were materials of science. It was about precision manufacturing, vacuum systems, electrical controls. From the start, Philips is an engineering company that happens to sell products, not very much an engineering company. That's very much their culture, and they sell products. And over the 20th century, Philips grows into one of Europe's great industrial institutions. They pioneer the development of radios, televisions, medical imaging, semiconductors. We know where that one's going. And they're one of the most ambitious corporate research organizations in Europe. And by the post-war decades, Philips Research, that national lab, is a place where physics is being taken very seriously, patiently, and systematically.
Yeah, and I mean, when they were involved early on in all this technology and older generations, they've seen the logo of Philips everywhere because many consumers had Philips made products. They were in vacuum tubes, and eventually, of course, they were from the very beginning involved with semiconductor manufacturing. So by the 60s and 70s, Philips ran its own fabs, own fabrication plants where silicon wafers were turned into chips through hundreds of control steps. And fab, like we discussed earlier, is not just a factory, it's a capital-intensive, always-on failure-intolerant system. Running a fab teaches you humility. You learn that tiny variations matter. You learn that uptime matters more than brilliance. You learn that suppliers are not abstract, they are existential. And Philips learns all this the hard way.
So now I think you're starting to see the story turn. Why did ASML come out of Philips? Because it was a light company. So lithography, where light becomes the bottleneck. So inside the fab, one step is more critical than a lot of others, and that's this lithography stage, which is how you print the blueprint of a chip onto silicon using light. As the chips get smaller and smaller, we have to use more complicated processes to basically achieve that transistor design. You coat a wafer with a light-sensitive material, you shine the light through a patented mask, and then chemically process the result, and you repeat layer upon layer. Imagine on each chip is like a miniature city. And you're basically shining the light down and creating the ground floor and then washing it away with chemicals. And then you shine the light on and then you wash it away with chemicals. And then you shine on, and you're having to do this hundreds of times per chip. And this is where things like yield, number of chips produced, basically comes into the equation, because this is really, really hard. But as long as the features are large, this is manageable. But by the 1970s, as we said earlier, the feature sizes are shrinking and the limits of light itself are being hit. Diffraction, wavelength constraints, and optical imperfections begin to dominate. Basically, lithography stops working. Yeah, a lithography as we can do it, and it becomes a physics problem.
Yeah, and I mean, I feel compelled to apologize to our listeners in one way. Lithography is the one that we are focusing today because we want to make a case on ASML. But this is not to say that all the other parts of producing semiconductors is any easier. Also, there are many critically important elements, and lithography is only one step that is extremely difficult to master. So we definitely appreciate the complexity of everything, starting from building the wafers to packaging and everything. There are innovations in all the stages. But anyway, getting back to the lithography, at this point, the global leaders are Canon and Nikon, and they are there because they were and they still are masters of optics. They know lenses, alignment, precision manufacturing. They know mirrors. And if you are running a fab in the 70s or in the early 80s, your lithography tools come from Japan. And Philips, as a company, understood and understands it very, very clearly. And the core finding of Philips is that it cannot simply outspend or out-engineer these companies who are way ahead, and they need to find another way of getting to the head of the competition.
Yeah, and it's not unfair to say by the late season, early 90s, Philips is under pressure. It's not failing, but it definitely feels constrained or maybe outgunned. The consumer electronics margins are tightening. This is where Philips had basically been a market leader, light bulbs all the way through. It's a company that's almost in existence for 100 years at this point. The capital demands are rising. The semiconductor roadmap looks infinite and insanely expensive. If I was the CEO of Philips at that point, I'm looking at this semiconductors business and going, this is just a money pit, right? The roadmap is insane and the capital requirements are even more. And again, Philips can see that the frontier of lithography is going to require hundreds of millions and billions of investment over decades, that there's almost no tolerance for failure. So lovely. And you could invest all that time, energy, and money on the wrong tech stack, yeah, and have it blow up completely in your face. So by the early 80s, Philips faces a real dilemma. Right? The rest isn't going well. It cannot afford to fully internalize this risk. Yeah, it can't really move forward with lithography capability. And the rest of its business isn't going that well because of the margins on consumer products and the rise of Asian manufacturing. And it's from this tension that ASML is kind of born.
Yeah, and I mean, let's remember, in the 70s and in the 80s, Nikon and Canon, they were on top of the photography and optical game. I mean, even consumer cameras were at the heyday. You had microscope, you had all kinds of optical equipment. So, I mean, those two companies had other businesses that were running very well compared to Philips that had other businesses that were in decline. So these corporations were in a very, very different situation.
I think you're absolutely right. Philips, it's not in a world of pain, but it's definitely feeling the pinch. And at this point, we introduce a character. We've spent very little time talking about people. We've mainly talked countries and industries at this point. But there's an individual that steps forward. His name is Arthur Del Prado, and he basically founds ASM International, yeah, on a belief that a not yet obvious semiconductor manufacturing equipment is not a support function. He believes that it's a category. And ASMI, Advanced Semiconductor Manufacturing, is entrepreneurial, it's customer close, it's commercially sharp. And let's just be clear, this is kind of a startup, not the Philips. And it lives in the fabs and it sees how the equipment decisions determine yield, uptime, and survival. And Del Prado brings real urgency and a founder startup mindset. And Philips brings depth and still got money, it's still got a good bank balance. But ASMI also has its limits.
Yeah. They do not have the research scale. They don't have the balance sheet, or they don't have the patience to carry multi-decade uncertainty alone. So the Philips ASMI partnership is not a marriage of equals. These are massively different size of organizations, but they have insufficiencies between themselves that they can compensate. So each side has what the other one lacks. Neither can succeed alone.
Yeah, and again, it was really interesting when we did the research on this, like understanding how ASML is born from effectively Philips going, I kind of don't want to do it, but I kind of don't want to get rid of it either. And then Del Prado coming in and going, I do want to do it, but I can't do it alone. I can do it with you. So this is this kind of classic joint venture is born. In 1984, Philips and ASMI form ASML. Sorry, the acronyms are all a bit close together, but ASML is effectively born as a company at this stage. It's a joint venture at this area, and the ambition is relatively modest. It's to build competitive lithography tools. It's to give Europe a seat at the table. It's to make sure that Philips doesn't step completely out of the arena, but isn't so much in the line of fire. And it's to reduce a bit of dependency on the Japanese suppliers. And let's just be clear, they're not sitting across the table from a venture capitalist saying, imagine what this will be like in, 50 years time when you're a monopoly and you can save more. That is not the conversation that they're having in 1984. They're having the Philips kind of doesn't want to do this, but kind of doesn't want to leave the party either. And you've got this really entrepreneurial individual in Del Prado coming forward and saying, look, I'll help you kind of step away, but still get some sort of benefit. But just to be clear, ASML is not born with a silver spoon in its mouth, right? This is under-resourced relative to the problem that it's taking on. So that's a real challenge. They are pretty much starved of capital from day one. And they're born into the reason that Philips wants to leave is this is a brutal, expensive business. Lithography and R&D is expensive. The customers are conservative. As you said, Martti, Canon and Nikon are on top of the world and they're winning. ASML burns cash. Its products are lag. There is no market share. And by the late 80s, it looks like this company is spluttered along from a small shed in Philips' back garden, and it's not going anywhere. And it looks like a European experiment that had basically failed.
Yeah, I mean it was not the most appealing place to be employed within the Philips empire, and the original CEOs and CFOs were not visionaries. They were survival operators. Their job was not to invent the future and conquer the world. It was to preserve cash, maintain customer credibility, keep engineers focused, and buy time, because time was the scarcest of resources.
Yeah, and some of the early founder engineers that I talked to as part of the research, like they didn't want to be there. Like they thought that this was Philips' way of laying them off without laying them off. Yeah. They were basically being shunted sideways into this crappy little company that would die within a few years. This was not, you've won the golden ticket into Europeans' monopoly. This was basically, you've got 1 foot out the door. They just didn't have the decency to tell you to your face.
Exactly.
Okay, crazily enough, ASML survives a number of near-death experiences. Philips and ASMI have to keep topping up the cash and the coffers. And in 1988, ASML goes public, which is like, how? How on earth are they able to go public? This is not a celebration. It's basically a survival event. It's Philips throwing them to the public market and saying, does anybody else want to fund this? And the IPO provides capital, not much. We're not talking meta flotation at this point. It provides a degree of independence from Philips and Philips' own internal politics. And it implies a bit of market discipline. And from this point on, ASML kind of lives or dies on its own merits. It kind of moves out a little bit from the parent shadow. It moves out of home. But it now has to kind of pay rent. It now has to get a real job. It's now fully exposed to semiconductor cycles. Yeah. and it doesn't have the insulation of a conglomerate parent to support them on.
Yeah. And what happens is that the people in ASML, they spend time in the fabs, they listen to their customers, they prioritize uptime over elegance of the solution, and that's where the Dutch instinct reappears. Get to know your customer, see what breaks, fix it. And the future success, how ASML wins the role it has today, it was brewing somewhere else, not in the hands of the engineers who were basically surviving day to day, week to week with the existing customer relationships. So they were definitely not winning yet, but they were learning production, not in theory.
Yeah, and again, I don't want you to have in your head of the IPO as a success. Everybody is suddenly a billionaire, stock options rule. Most of the employees got rid of their stock as soon as they could. They thought the company would fail, right? They thought this was just another last-ditch effort to keep this miserable startup going. This is not getting rich through stock options at this flotation. But I do think that this point in time, ASML goes public, is when the people begin to crystallize. We start to get the right people on the bus, right? The people who want to be there, the missionaries. The others weren't mercenaries, they just got chucked out of Philips, right? But we start to get the people who believe. And there's one individual, and there's a number in this story, but one individual we need to really single out at this point. And this is a chap called Martin van den Brink. And he joins AS 1988. Yeah, and within 2 years, and there's no question, everybody we talk to says that Martin is brilliant, right? Probably one of the smartest people in the industry, one of the smartest people on the planet. And within 2 years of basically joining ASML from Philips, he's become effectively this CTO, Chief Technology Officer position. He's deeply technical. He's deeply patient. He's actually very controversial. He's got very abrasive style. If he doesn't like what you say, but he wants to hear the truth. He's a truth seeker. And he's also convinced that lithography will only get harder. Wow, what a sell hardship to your employees. What a great guy to have. And alongside him, you get some other really founding engineers and individuals like Joe Spenshop, and he helps turn engineering ambition into manufacturable systems. If Martin is the kind of mad scientist, Joe is the system engineer character. And then you have these commercial and financial leaders who insist on customer relevance. ASML doesn't have cash. They have to listen to their customers. They have to their customers. They don't have a choice on that side. And they develop this kind of dual logic. They have to have horizon thinkers like Martin who are looking decades out, but they also have to survive today. Yeah, so it's that classic startup dilemma. I need to look to the future horizon and what this could become, but I have to also survive today and sell to my customers today. And again, it is a tension, but it's also becomes, I would say, becomes the ASML culture today and tomorrow, and they have to do both.
Yeah, and if my memory serves me right, they were looking for another CEO for the operation as well, but eventually found out that Martin was the one who was able to deliver. So they stopped searching for another one. And it's important to understand that one of the successes of ASML in this period was that they were able to deliver. And that's what the management style, what was brought by Martin to the organization, that's what it produced.
Absolutely. And again, ASML, and again, we've painted a picture of them customer obsessed. They're customer obsessed because they need the cash, but it's also, I would say, in their DNA. And by the early 80s, ASML is starting to change, right? Kind of understands its place in the village of the semiconductor industry is to become a neutral party, to play with everyone, not to take sides, not to form alliances. And the mission it's taking on can't belong to one parent or one industry. And at this point, early 90s, Arthur Del Prado, he's moving on. Yeah, he's basically delivered he's helped launch the company, but he's no longer one of the key leaders. And he's built this kind of culture and business, and he steps away. But without him going to bat with Philips and trying to persuade them to basically put ASMI and ASML into existence, it never would have happened. Where I get to this by early 90s, ASML is alive, Martti, but they're very fragile, right? They're kind of one player amongst many, and they are also one technology amongst many. The village at this point is not under too much pressure, and there is a range of different technologies that they could act on, and ASML is playing one of the roles and championing a few of the technology stacks. How does that feel to you at this kind of end of Act 2?
Well, I mean, it's like what we're going to talk in Act 3 of this story is that by trying to reach the dominant players was not enough. What was needed was a step change in the technology that essentially muddied the waters of all the players. All of a sudden, there were several technologies that were competing with each other to become the next generation of lithography. And when there is this disruption of the market, in order to maintain Moore's law, in order to serve the customers with ever improving chips, there was this disruption of the technology, and that then opened up the opportunity for ASML to reach the other players.
Okay, so let's look at Act 3. So by this stage, listeners, we've established ASML as an entity. We've introduced the industry, talked about some culture and DNA points. They're going to come through stronger. But by the early 1990s, the semiconductor industry starts teaching ASML its first. One of the many lessons that ASML is that the semiconductor industry is a cyclical industry. Not in theory, but in lived experience. In a boom, the fabs are full, utilization is high, capital budgets open up. In a bust, orders freeze, purchases get cancelled, inventories pile up, and strategically important milestone and investments are paused. Right? And the key asymmetry is this: demand moves fast, supply moves slow. And a leading edge fab takes 3 to 5 years at this point to plan and build. And these tools ASML is starting to create, these lithography tools, they're ordered years before they generate revenue, right? The ASML has to accept the order, build the machine, and long-term later get paid. And by the time the machines are delivered, the world, in a fast-changing, every 2 years, number of transistors doubles, etc., the world often looks very different. And ASML is kind of born into this rhythm of boom and bust.
Yeah, and I mean, this matters because lithography tools sit at the sharpest edge of the cycle, being expensive, long lead time, and mission critical. In the 1990s, a leading lithography system costs tens of millions of dollars per tool. Buy them casually. They buy them whenever they believe the next node will pay off, because everything is, I mean, the cost of goods sold, the added value that you bring to the end user is all the time in the hands, in the minds of all the executives, because we are essentially talking about consumer business. These are the years when consumer applications start taking over the majority of the marketplace of advanced semiconductors. And this is a global important trend to realize. So whenever the optimism spikes, orders surge, and when fear sets in, orders all of a sudden disappear. And ASM early P&L reflects this volatility in a brutal manner.
Yeah, and again, there were lots of stories in the research of ASML almost being, we're F, it's all over, multiple times. Right. So, the first early employees that went across from Philips, they thought they were stuffed. Right. Then ASML goes public and most people sell their stock. And then there is literally 4 or 5. We're not going to recount them all because there's too many near-death experiments in these first 10 plus years of ASML. So let's put some numbers on it, because without them, it kind of doesn't feel real. So by the early to mid 90s, so ASML founded in 1984, 10 years old, ASML revenues are hundreds of millions of euros, not billions, millions. Profitability is inconsistent, I think is a kind word. Some years is profitable, other years, many more years, they're loss-making. R&D spending is high as a percentage of revenue because it has to be. They are doing a really difficult edge of the law of physics jobs. And Canon and Nikon are still way bigger, yeah, and further ahead in technology. It's not a position of strength. And even in a good year, ASML does not feel safe. And again, this is the culture in which ASML employees live.
Yeah.
Day-to-day cash crisis. Is my company in existence? Are we not even winning? Are we going to go out of business tomorrow? Selling to customers that sometimes, yes, we want our machine. No, there's been a bust. No, we don't want it anymore. That's the existence of those employees.
Yeah. And I mean, inside the psychology of the company employees, even a single strong year doesn't buy confidence, because everybody remembers the bad years that you had not so long ago. It buys breathing room. Everybody inside ASML knows that the next downturn will eventually come, orders will once again dry up, and the cash discipline will matter again. So rather than having this freedom to move, every strategic conversation you have, every single management meeting, every strategy workshop you have, they are under a shadow of next forthcoming failure.
Okay, now we've not talked that much about the machines themselves, and I think we need to, right? ASML is basically shipping deep ultraviolet or DUV lithography systems. So DUV is the acronym to kind of home in on. That's what they're shipping. And these include transitions across I-line systems, KRF, and then the ARF. And again, these are different systems that basically take the nanometer scale down. And each step matters, and each new wavelength allows smaller features to be basically placed on these chips. But when you go smaller, you go more expensive. So it's always at a higher cost with very tighter tolerances and more complexities. And ASML machines at this point are not the most revolutionary, but they're becoming to be competitive in the market. Customers are starting to trust ASML, right? They're not out of business. They've shown this grit, persistence, die-hard attitude. They're the Dutch equivalent of Bruce Willis getting shot in his white vest. They're not dying, and they are starting to be competitive. Certainly with the DUV machine.
Yeah, and each of these systems at this stage, they cost around 10 to 30 million depending on the configuration. They come with long installation cycles, require intensive service and support during the life cycle of the system. Of course, the plus side of this is that the revenue is not just from the sale of equipment. It's revenues coming from having the uptime service contracts and repeat business. So one successful deployment can mean follow-on orders, process alignment, long-term customer relationships, and this is how ASML slowly but surely builds a great installed base of systems.
And there's a lovely story, Martti, I don't know if you heard it, where Martin, basically the CTO, goes to visit a customer, helps install this first DUV machine. It's working. He leaves. All good. And then meets up with the customer many years later, to kind of almost reminisce about, we installed the first machine with you. And he went, yeah, I remember. Because as soon as you got on the plane, it broke. And I had to spend 2 months trying to fix it and not get fired by my boss because they hated it. And again, we called them machines, but ASML really refers to these as tools to do a job. And this will come up later, but I do think the language is important because these are really complicated machines, which we'll get into, and they don't work perfectly all the time. And this is where effectively ASML's culture of stay close to the customer is super important, because you're not shipping a finished product here. Yeah, you're basically building with the customer in their fab or factory. And to kind of bring this to life, let's walk through one cycle. Because this is how ASML experiences the noise. So first, the demand rises. PCs, personal computers, Microsoft's, a computer on every desk and in every home, kind of quote, PCs proliferate. Servers start expanding. Semiconductor roadmaps accelerate. The chip makers invest. The tool orders increase, tools, ASML machines, ASL order book fills, revenue rises, margins improve, and confidence returns. So, this 1990s or the mid 1990s onward kind of starts to look up and to the right for ASML because of the drive of semiconductors inside the personal computers, which are starting to arrive in every home and on every desk.
Yeah, and the capacity arrives, new fabs come online, supply catches up, prices soften, and then all of a sudden demand pauses, orders are delayed, many orders are cancelled, capital spending freezes, and ASML is the one that feels this immediately. The revenues drop, costs don't, and the company tightens again. So, essentially this boom and bust cycle was tormenting them once again.
Yeah, and again, if I was an early ASML employee at this point, I'm kind of got this yin-yang diagram in my head, right? I've got the kind of, we're amazing, personal computers are arriving, semiconductors are happening, we're going to the moon. That's on the kind of the black side or the white side. And then the other side is, we're dead, it's all over, nobody's ordering anything, and we have this cycle, right? That you just feel that you're completely trapped in, right? This kind of boom and bust cycle, while trying to basically beat the laws of physics. So again, each cycle reinforces the same lesson. Incremental success does not equal strategic safety. ASML can execute well, but it's still vulnerable. And again, the only safety is staying close to customers, right? The only safety is building not just what the customer wants, but building with the customer. Yeah, to create the capability that not they want, but they need to keep pace with Moore's law. So by the mid to late 90s, ASML customer list is changing, right? They started shipping tools, but the customers that are shipping them to a new set of entities, and we need to name them. So Intel is pushing leading edge logic aggressively, and it's very much the node leadership of the semiconductor industry. They are an ASML customer. TSMC, very well known today, completely unknown then. Taiwan Semi Manufacturing Corporation, TSMC, founded in 1987. Again, remember the date. 1987 is TSMC's founding. 1984 is ASML's founding. They are contemporaries. This is the Amazon and Google of their day. They're born close to each other. They're pioneering pure play foundry model. They don't design, they manufacture. They don't make their own chips. They don't compete. They manufacture. That's Morris Chang's big insight and breakthrough. And its entire credibility rests on delivering new nodes to other companies. And then Samsung from Korea is scaling aggressively, and they're determined to compete. They are the yin and the yang of Intel, determined to compete at the highest level of memory and logic. And again, these are not casual buyers. When you're selling a tool to these companies, you are selling them a capability that they need. And if they don't have that capability, it's not a question of them not being happy. They're in as much trouble as you are. Yeah. You're going to feel as much pain as they do if this thing doesn't work.
Yeah. And of course, for somebody like ASML, having TSMC, which is the fab without circuit design that enables the fabless chip factories, the chip designers who can then subcontract to the manufacturing to TSMC, of course helps ASML because there are less organizations that you need to deal with, and TSMC of course becoming hugely large, and these, even if let's say the ecosystem gets smaller, these three dominant players are very different. Intel definitely wants certainty and speed, TSMC wants reliability and repeatability, and Samsung wants scale and leverage. ASML is learning to serve all these three, and that forces discipline from their part. It also exposes ASML to a deeper truth. These customers are beginning to worry about the same thing, which is Moore's law under pressure once again.
Yeah, and again, just going back, listeners, in our Airbus episode, we talked about how great companies are often forged in their competition with great rivals. Airbus and Boeing, or, was a great rivalry or is a great rivalry, which has forged the path of both companies. I'd say here that ASML is also forged by its great relationships with its customers, right? Or its relationships with its customers, I'm sure at times were very not great. And ASML basically got in a lot of trouble when they went to conferences repeatedly, said, it's going to work. And you said, at TSMC and Intel said, you said that last year and the year before that. But I would say that the relationship between Intel, TSMC, and Samsung is super important. And this forges ASML's culture and practices very strongly, working with these businesses. And I do think it's very important that TSMC particularly is born at the similar time to ASML. They kind of grow up together, kids from the same streets, on the same school, etc. But as Martti, as you said perfectly, Moore's law at this stage is under pressure. And as nodes move towards 180 nanometers, 130 nanometers, 90 nanometers, we're getting so small. Yeah, the cost per node transition rises sharply, and what we call multiple patterning becomes necessary. It just gets super complicated to build these miniature cities of transistors and infrastructure on a chip. And the industry, again, responds with various workarounds, tweak this, but the economic cost is rising. And really, at some point, and I would love to have been a fly on the wall in some of these industry conferences they had, and I read a number of the minutes, but at some point, the question seems to shift from, can we do this, to should we keep doing it this way? Almost, are we mad to continue to believe that we can go smaller and smaller? That seems to be the conversation.
Yeah. And this is where the industrial cycle and the physics intersect in an interesting way. In boom times, complexity is tolerated. There's money, and you can explore all kinds of avenues. But in downturns, it becomes all of a sudden unacceptable. And customers began asking harder questions. How long can we stretch this? What is the next real step? Who's responsible for that step? What's going to happen next? I mean, these are tough questions when we are dealing with matters that are at the scale of atoms. All of a sudden, atoms start representing the scale of matters. And these questions don't show up on purchase orders. They shape strategy.
Okay. So hopefully, listeners, you've stayed with us long enough, because at this point, inside ASML, the conclusion is starting to form slowly and reluctantly. The DUV, deep ultraviolet lithography, can be extended further, but each extension buys less time at more money. So they're kind of going, oh, this isn't working very well. It's going to cost more money, and we can only extend it and extend it and extend it. And each time we do it, it costs more and we get less. And the extreme ultraviolet, and we need to unpack what that means, the opportunity to drop down to 13.5 nanometer light offers a potential way forward. Okay. But let's just be clear. EUV is not a product upgrade. DUV to EUV isn't an alphabet change. This is a system reset. So again, we go from lenses to mirrors. We're talking about operating in a vacuum. We're talking about new light sources, new materials, new suppliers. This is the throw everything out and go from first principles in a new direction. This is not something that you trial quietly. And this is a company that is only still surviving. Some years profitable, some years not. But basically the conclusion becomes inevitable.
Yeah. And this is the point when we need to yet again go back to the 80s, to the lovely 80s, because at the time when Maurice Chang was establishing TSMC and Martin was putting together ASML, we had a Japanese scientist, Hiro Kinoshita, who around 83 found an interesting study paper about using multi-layer mirrors to reflect and control X-rays. Why X-rays are relevant for this case? Extreme ultraviolet, it's not light. We are talking about X-rays. And X-rays have funny properties. They are not behaving like light in itself. And Kinoshita found this study paper that you can actually control X-rays. And he eventually dealt with 11 nanometer light and was able to actually build a proof of concept of a lithography machine using X-rays, using 11 nanometer waves, and he was of course extremely happy. His team put together this prototype or proof of concept, and in 1986 he went to present his findings to the Japanese Society of Applied Physics, and he was so proud and excited and explained his setup and showed the image, but the audience refused to believe him. I mean, he was essentially ridiculed and thrown out, and his whole academic reputation was put into the jeopardy because what he was proposing was outrageous. You cannot control X-rays.
I kind of had my image when you told me about this, and I did my
Yeah.
own research of
Yeah.
him being kind of almost, the UK equivalent of being, rotten fruit peppered at you in the kind of medieval market for basically saying that the earth, is not the center of the universe. Like, this is like heresy, what he's suggesting.
Exactly. And I mean, when we remember that the Japanese society is all about saving your face.
Oh my gosh.
I mean, if it feels bad to you in Japan, it's as close to being killed than anything else. At the same time, and once again, we are not in the Netherlands, we are not in ASML. At the same time, in the Lawrence Livermore, in the nuclear fusion research, there was a challenge that they had difficulty in measuring X-rays, having the ability to study what happens in the nuclear fusion research, and then this whole idea of using multi-layer mirrors to use for measuring the events was found. And there's another protagonist to our story, Andrew Horlick, who within a few years with his team used multi-layer mirrors to reflect some X-ray light. And but when he had a visit in 1987 from a professor from Cornell University who was very impressed, but he said that, well, great, but there's no practical use for that. And Andrew, powered by this doubt from a professor, during Christmas time in 87, he started writing a white paper. And for 10 days during Christmas time, he wrote a multi-page paper describing how you can use the mirrors in lithography applications. And what happened to Kinoshita happened also to Horlick. And he went 5 months later in 1988. He went to a conference, presented his findings, and he was literally laughed off the stage. I mean, the stuff that you say cannot be done, and everybody was essentially saying that this is a stupid idea. And when Andrew's boss asked how did it go, afterwards he commented, "I will never speak of it again." And of course, there's always a nice story here. A few days later, he got a phone call from somebody called Bill Brinton. He was from Bell Labs, and he was the
Very
executive
famous
vice president of AT&T, and he wanted to hear more about this. And then eventually, when we get to the point that the deep ultraviolet lithography met its limit, there was the opportunity to build on the experience and the research that was done in Japan, in United States. At this stage, not in the Netherlands, not in Europe, in Japan and United States. Of course, the problem, EUV was not the only solution. There were other solutions also to reach the next level of technology. Canon and Nikon were very much aware of EUV as one solution, but eventually what they came up with is that because there were these parallel opportunities, how to reach the next level of precision and scale, there were several alternatives. And what happened was that Canon and Nikon, they just didn't believe in EUV as an alternative, quite the same how eventually then ASML wanted to consider this. And of course, I mean, it sounds simple. You just take a shorter wavelength and do the same stuff that you've done before. But the technical challenges in order to make this happen, just to get a source for the specific wavelength of X-rays was a tremendous challenge. And definitely in those years, for most of the observers, what they were planning to do was impossible.
Yeah, I think, Martti, I love the story of almost the founding of EUV. and the way you painted it. So the two inventors of EUV basically got pillared by the academic community as idiots and madmen. And then this is the technology that ASML are going to take on and kind of bet the house again. And again, I do think that kind of decision does require a little context. At this point in time, hopefully we've painted a picture. ASML is a public company, but they're also different. They've been in this cash-starved, brutally cyclical industry. They don't have a dominant install base to protect. And they do not have a stable, predictable cash engine. This is not Google, right? But they do have systems engineering depth. They do have customer proximity and relationships. They know what their customers need to build. And they do also have the scar tissue from this volatility of, being duffed up and scuffed up a lot. And I think at this stage, and I would have loved to have been a fly on the wall in these conversations, I think this is a Dutch characteristic. They kind of say the thing that they should not say. Yeah, they say the thing that effectively, if we stay incremental, we will be a hostage to the cycles. If we solve the next node, we might. No, it's too tough. We actually, even though what we're doing at the moment isn't perfect, it isn't great, and isn't truly working, but it's keeping the village alive, it's not enough. Yeah. And they have to find a structural difference. And I think, that ability to be Dutch and direct and call out the elephant in the room, I think that's really important at this point.
Yeah. And I mean, what happens in the early 90s, when the Cold War ended, there were many strategic technologies. I mean, the ability to reflect ultra deep or extreme ultraviolets or X-rays, they were strategic technologies that were very heavily funded by US government.
Yep.
When the Cold War ended, there was a deliberate attempt of trying to work to have the national labs work together with the industry to find industrial applications for all these technologies that had earlier been developed as part of the national security landscape. And there was a lot of funding that came from the US government for this development that eventually then dried up around 1996. ASML had wisely worked together with the American research communities in the programs that existed. The Japanese companies were, let's say, interacting with the research, but actually ASML at this point was able to get closer, was able to have a real insider view. I mean, they essentially cunningly, they got inside the, let's say, the research realm that happened in United States. And there was no other lithography manufacturer from United States to compete, and the Netherlands, being a trusted close ally, was able to act as an allied source for this capability, and that's what they did. What happened in 1996 was that when the government funding dried up, then the three key industrial players, TSMC, Intel, and Samsung, were in a pivotal role in getting commercial money to continue with the research. And I mean, Intel alone put more than $4 billion. And then Samsung and TSMC combined, they were well north of $5 billion that was invested into taking this EUV forward. Intel was working with other technologies at the same time, but eventually they chose that EUV is the ticket that we believe in.
Yeah, and again, I think I want to put a pin in the concept of, could ASML have been invented in America? Could, and I want to come back to that later, not now, because we're still telling the story. But at some point, we need to circle back and look at a counterfactual around whether ASML could have existed as a US company, and an equivalent to ASML could have existed. But at the end of this Act 3, and as we move into Act 3, I think the summary is this. The industry is still cyclical. This is early 2000s. ASML is still financially not in a great position. DUV still works barely. The ASML has come to the conclusion, and some of the industry has as well, is necessary, but it's terrifying in the complexity of what requires to kind of move forward. And as we enter Act 4, and again, we talked about this briefly at the beginning, this is really for me, when I was looking at this, trying to get a hold of the framework here, this is this kind of the village standing in a circle, like who amongst us will go on this suicide mission to basically go and build EUV, and the kind of blonde Dutch villager kind of steps forward and basically says, I'll go, and everybody wishes them luck and puts a bit of money in their pocket to back them, and behind their back goes, they've got no chance.
Yeah.
This is madness. I'm glad I'm not going. We need them to go, but I don't think I would do this job.
Yeah. And I mean we're not going to go into details on the alternative lithography technologies that were considered, but one of the key elements was all the time, in addition of getting to smaller and smaller transistors, what is your production yield? It was all the time, it was about the cost of the item for the end user. So you had to have speed, you had to have affordability at the same time when you are increasing the performance of your item. And these objectives are working against each other, and really the technological innovations that they decided to conquer, they were extraordinary, because you are at the same time you are making it more affordable per operations, and at the same time you are building capabilities that were not available using the earlier technologies.
Yeah, so again, we're at the early 2000s, and I think at this point the industry stops pretending. Like Moore's law has gone from a law of observation to basically almost like the pace at which the industry moves. It's alive, and DUV is still working, but increasingly painful. We can extend, but it costs more money. We've said before, EUV is necessary, but terrifying. And again, we talk about the industry coordinating. Now, please, listener, don't think of this as a cartel or a conspiracy. We're used to those words when we talk about industry collusion, etc. This is a survival mechanism. This village is under real threat of being burnt down and nothing working for anyone. And at this stage, the industry is coordinating because the problem has outgrown single firms' ability to solve it.
Yeah, and it's the whole coordination isn't just a handshake and good feelings. It's things like when we talk about mirrors, it was Zeiss who chimed in. I mean, ASML could not develop the mirrors to the degree of success. It was all Zeiss who did it. And eventually it was originally a company in San Diego who was the mastermind with the EUV source, eventually acquired by ASML. This whole machine, the lithography machine, is actually a system of individual systems where each and every supplier needs to bring their own deep technological knowledge and expertise for ASML, for eventually to assemble and integrate the entire working system. And within this village, this ecosystem, the coordination means that you have multi-year capital commitments, you are sharing roadmaps, you are sharing risk tolerance, you are sharing engineering labor, and you have agreements on what the next step is. I mean, this is a true long-term committed partnership.
Agreed. So let's name the place where the clock gets set, or the village meeting takes place, like Fellowship of the Rings. So for decades, the semiconductor industry has had this unusual institution, a road mapping progress that tries to turn the chaos into a shared plan. And it's called the International Technology Roadmap for Semiconductors, or ITRS. Now, let's be clear, it's not a company, it's not a regulator, it's just a coordination mechanism where everybody comes together, all the companies, and they converge on their best current estimates of what happens and when. And the matters is because the technologies don't win in semiconductors by being clever in a lab. They win when the roadmap for the industry converges.
Yeah, and you could consider ITRS as the industry's shared metronome. It's the pacemaker. It tells suppliers, customers, and research labs, here's the capability of the ecosystem needs by this specific date. It doesn't force anyone to do anything, but when the roadmap converges, everyone can see what happens if they don't align. There's going to be duplication, incompatibility, delays, and the collapse of the whole tempo of progress. Because the end users, the chip designers, the Apples, the Intels, all these companies who are eventually going to be using the chips, if they don't see that a chosen path is helping there to fulfill their strategy when they are trying to serve their customers, they start immediately looking for other alternatives. Because even for the EUV, there were other technologies that were then phased out at one point. But if EUV eventually turns out to be not the winning ticket, the Intels and the TSMCs and the Nokias and Apples, who were huge users of the microchips, they are not standing idle. They start looking for alternatives. And that's why this whole thing and the pressure of being able to follow the roadmap is tremendous, and it is understood by all the players.
Yeah. And as we said, basically, EUV becomes the thing that the industry coalesces on, but it's a big change. It's a complete system rebuild. And again, you talked about this briefly earlier, Martti. The normal market model breaks. Yeah, okay, we're saying, hey, Dutch villager, go off and carry the can for the sector. But we need to put some money in your bank balance to basically go off and take on this impossible mission, because no single company, no villager wants to pay for this alone. And no, ASML is not rich at this point. It can't afford to pay for it either.
Yeah. And it's I mean, when we talk about a village, it's not metaphorical. It's a financial commitment as well. Exactly like the business model of Airbus. I mean, you cannot afford taking all those financial risks all by yourselves. You need the partners that will share the risk and share then the outcome of the joint production. And it is very important to understand that here, even if the engineering challenges are extreme and important, there's also the financial and the business risk aspect that is bringing the village together.
So at this point, Dutch villager ASML steps forward. And again, I think they have two qualities that the village needs. They're neutral enough. Again, they came into the sector wanting to basically sell tools to everybody, not sell tools to a few. So they're seen as neutral. They're seen as outside the incumbents. And they're basically battle-tested, scarred enough, mad enough, whatever your framing you want to do, is that this is the mad villager that you're going to bet to take on the suicide mission, because fundamentally they've proven in a kind of Bruce Willis type way that they just won't die. The industry has tried to kill them many times. They have survived. And so they are neutral enough and battle tested enough to effectively go and take on the mission.
Yeah. And I mean, funnily enough, I mean, if we are talking about the startup logic here. I mean, the investors are appreciating those founders who were able to pivot, those ones that were able to solve the problems that came their way. And the scarred enough is actually a very, very important element here. It's much more important than people probably think, because a normal company treats uncertainty as a problem to eliminate, but ASML treats uncertainty as a condition to operate within. That's what near-death does. It builds an organization that doesn't confuse discomfort with danger. So when EUV begins failing in new and humiliating ways, ASML doesn't interpret that as a stop. It interprets as we are early, which actually, while they were perfecting the technology, was quite painful for the big three customers to follow, that were growing. That they were growingly impatient in seeing that ASML is meeting the promises they've made.
Oh my goodness. And there is so many stories here. And again, let's crystallize it in one person. It's not one person, but effectively, if you've got a picture of this Dutch villager going off and doing the suicide mission, picture Martin van der Brink in that starring role. He's Tom Cruise in this movie, right? And again, he's just a figurehead. There's 1,000 people, hundreds of thousands of people that did the work. But effectively, he becomes more than just basically the CTO of ASML. He basically sets the roadmap for this area, for the industry. right? He can walk into the rooms with the Intel engineers and the TSM leadership and the Samsung technical teams. They might not trust that everything he says will come true, but they at least have a really detailed conversation about absolutely everything, because he has credibility in two worlds: the deep physics of lithography, and he very much sets the roadmap for this sector. And he's in the fabs with them. He understands that the machine breaks, the tool breaks, and he has to work to fix it and understand the ugly realities of production in a fab.
Yeah. And this is where the customer obsession point becomes real. In software, customer obsession means A/B tests. In lithography, customer obsession means standing in a fab at 2 a.m., watching the defects appear, hearing operators describe failure modes, and then translating that into engineering priorities. So a big part why the village holds is that the customers that believe in ASML, and they are not hiding just behind PowerPoints. They are there. They are deep in the problem themselves, and Martin as an individual is definitely the embodiment of all that spirit. And of course, I mean, Martin is also brutally honest in not selling certainty. He's selling honesty with a path and mission, and the promise that eventually we're going to get there. But like we know from the history, the schedules have been elastic, to say the least, at some times.
Yeah, this lot make Elon Musk look like a truth teller in terms of their ability to slip timelines on self-driving cars. Oh my goodness. Yeah.
Let's not get into that now.
No, but the schedule slip. There's no question about that.
Oh yes, absolutely.
Again, hopefully we've painted a clear picture. The village basically funds the program. ASML can't afford to do it. In 2012, as Marty mentioned earlier, Intel, TSMC, and Samsung contribute billions over 5 years to accelerate next generation lithography R&D. And again, let's just be clear, this isn't normal, right? This is them being desperate. And they don't normally fund suppliers like this. They do it because they have to.
Yeah, and it's even deeper than that. The co-investment program also included customer buying equity, a structured alignment of incentives. The SEC documentation around the program described customers acquiring an aggregate of 23% minority equity stake for $3.85 billion in cash. I mean, huge amount of money. And the structure included a synthetic buyback mechanism to return cash proceeds to other shareholders. This is the industry saying, we are not just ordering tools, we are underwriting the roadmap, and we are jointly working together to reach the goal that is needed for the next generation service level, the next generation value proposition. And that's a village with voting with money.
Yeah, and again, listeners, this deal is referred to, this investment in 2012 in ASML is known as the Three Musketeers, right? So Intel, TSMC, and Samsung are known as the Three Musketeers. And if you remember back from your kind of French history, this is all for one and one for all, right? This is the spirit of cooperation that's entered into. They're aligning incentives because they're desperate and they need this to work. So effectively, if EU fails, everyone's future is worse. And if EUV succeeds, everyone's future stays possible for a little while. The industry really chooses survival over isolated heroics. But again, I do want to underline a point at this point that ASML literally in all the literature, all the podcasts, everything you read about ASML, they do not call these tools that they sell machines, right? That's the outsider's view. We talk about these DUV machines and EUV machines. We talk about them in the fact that they're tens of millions, hundreds of millions, 400 million. They take 3 jets to fly them to the customer. Yes, they are the world's most complicated machines, and we get into why, but they call them tools. And I don't think that's branding, Marty. I think that's very much a very different mindset change. A machine implies I build the machine, I send it to you, and it works. And what ASML is selling is tools, right? I make this thing, this knife, this thing that does a job. It is shaped through use. It changes over time. it's refined through practice, and it's improved through shared learning. EUV tools, when they do arrive, certainly do not arrive as finished product. They arrive as a promising start.
Yeah, and I mean it's also good to realize that when we talk about the major players in the fab business, you are not selling a product. I mean the product in itself is definitely just a tool. You are selling a capability of reaching the next level performance in your microchips. And it means that there needs to be a constant dialogue between the supplier and the customer, which is not that very different compared to national security and defense applications, where you are indeed, I mean, the stuff that we sell to the military customers and to the government, they are not the customers are not interested in the items that we sell. They are interested in the capabilities, the warfighting capabilities that they are able to achieve by using the stuff. And of course, they need the people and they need the concept of operation, etc. But we are talking about capabilities, and the tools are just tools, nothing more. And this is why actually the ASML relationship with their customers is very similar to what we see in national security. It's not transactional like the typical supplier customer relationship that we describe. You deliver spec, you get paid. EUV, the lithography is not like that. It's about co-development, it's co-creation, it's shared debugging, it's shared learning loops, it's a mutual willingness to live through imperfection in order to reach the capability. And the capability is needed to have the value proposition to the next stage of customers, where you have Apples, you have Nvidias, and eventually you have, in more often than not cases, you have consumers that will be then the ones who actually get the capability. And this is just the supply chain for building that capability.
100%. And again, we're not going to fully unpack the supplier village yet. We're going to do that in Act 5. But I think before we move into that, we need to introduce this structural truth. EUV cannot be built by ASML alone. Yeah, the suicide mission also needs kind of an extra. It's Harry Potter needs to go on the quest with somebody, right? Yeah, he needs his Ron and Hermione. So ASML becomes an orchestrator of specialists. And one of those specialists we know pretty well because they were on our prior episode. And that is Zeiss. Yeah, so Zeiss is critical to basically building EUV.
Yeah. And they are essentially an existential supplier due to the fact of EUV, the X-rays that we want to control here. You need the optical capability that the Zeiss is representing. The ASML's own product praises pages describe its EUV platform as a system, and EUV light is there to enable the most advanced chips. But the optics, the mirrors, they are the heart. Without that capability, EUV is not late. It's impossible. And the same thing goes for many other components. It's so critical to understand that because ASML is not vertically integrated, they are entirely, thoroughly dependent on the key suppliers like Zeiss. So when we say village, we mean that customers are underwriting risks, but suppliers are making the physics real. So when we see ASML is essentially, it's like the conductor of the orchestra. You can't and you won't do everything yourself. You are just there in the middle and you are playing your own specific role, which is not trivial at all.
And I loved reading some of the documentation around this ASML Zeiss relationship, because obviously we'd studied Zeiss really intensely for the last episode. So we knew Zeiss really well. And then this is almost kind of meeting their brother, but it's a brother with a very different mindset. You know, in the conversations that you heard, research that I did, ASML comes out as a cowboy at this point, right? ASML's the kind of radical, we need to do this on behalf of the village. You know, they've got the kind of hero main character vibe, and they are pursuing this very aggressively. And Zeiss comes out as very much the kind of scientist that they have to kind of persuade to come on the journey with them, right? That does worry about, can we do this? that is very practical, that is very much worried about the balance sheet. And again, we know Zeiss's culture, so we know that they're not against taking risks, but this is really the hero saying, we need to do this. And then this is one of the other protagonists and gang members saying, okay, but. It's really interesting. And there were times when ASML basically goes, and they didn't have the bank balance for this, but I loved it. Like Martin's like, well, we'll just buy you. You know, you're not going to cooperate with us. We'll just basically own you and move forward. They didn't have the money for that. But it was really funny to hear about those conversations on that aspect. So let's talk about money for a second. So by the time EUV is coming from this project to product level, ASML's overall business is no longer so small, right? So in 2015, ASML reports full year sales of 6.3 billion. We have a billion in the wording, and their gross margins at 46%. And the net income for them is 1.4 billion. So we're starting to make money. Now, remember, fabs take cost billions themselves. So, you know, this is a billions world in semiconductors. But we're no longer surviving quarter by quarter. And it now has a financial engine to keep investing. And I think that's important. Yes, ASML needs support of the village, but it's no longer completely broke and about to die itself.
Yeah. And I mean, in 2015, ASML sold 144 new systems, and the service options hit about 2.0 billion, which is very important to understand in this whole earning logic and revenue stream. That's the shape of an infrastructure company actually emerging, where you have systems revenue, you have recurring service engine and service revenues, and you have a deep integration into fab operations, which is your customers. Once you have that install base and service footprint, you become very hard to displace, especially when the specific technology that we represent is not mastered by many. And for example, Canon and Nikon, they continue to be in this business, only not with the EUV technology that ASML was able to tackle.
Now, we're 2015, and we're recording this episode, listeners, in early 2026. 11 years ago now, ASML commenced. It states it met EUV productivity and availability targets, and it begins shipping the NXE 3350B. Catchy title, great marketing. And it's described as its 4th generation EUV system. And again, I think this matters out to market in 2015. And it's the point where EUV becomes a platform with generations that will go forward. And once there are generations, there's no going back. ASML has committed.
Yeah, and I mean, the generation story, there was an interesting story that when they were dealing with EUV, they even hadn't been able to have the first generation operational when they already started planning and designing the generation 2. So you have to be so far ahead that you are planning generation 2 even when the first is not yet operational. Anyway, the village.
No, I love that concept, where then there was a story about them, you know, Samsung finally running out of patience.
Yeah, well, I mean, that was
ordering the ASML executives, Martin, etc., get on the bloody plane and show the results that this actually works, or you will be, for want of a better word, summarily executed when you arrive in Seoul.
Yeah, and I mean that story, if my memory serves me right, was about having the EUV source producing 200 watts power.
Oh my gosh!
And when Martin boarded the plane in Amsterdam, the tests were ongoing, and when he landed to Korea, then they had the first proof that they are able to produce 200 watts. And that was really the moment when the patience of the Samsung customer was about to run out. So I mean, talking about the very, very last minute success, but it shows. I mean, the fact that you are able to produce in a controlled way the X-rays in this wavelength, it's a massive story. I mean, essentially what they are doing is that they are shooting little droplets of 3 times in order to produce that X-ray light. It's an amazing process, and now they are at 500 watts with the same technology. But I mean, it's the the X-ray source in itself is worth of a separate story. So really fascinating.
Yeah, and
Anyway,
again, listeners, we're not going to dive deep into the machines themselves because actually there's a lot of good videos on the internet that actually explain how these things work. But fundamentally, I think if you have a picture in your head of a ridiculously complicated large machine that does something that we almost think is totally impossible or is impossible, shooting droplets of tin with a laser 3 times in a second in a vacuum with a power, creating a sun on Earth. That's where it's going. Look on the internet. There's plenty of information on these particular machines. And again, I think what's fascinating is they take the risks and they pay off. And this is something that we kind of started at the beginning with. ASML becomes a monopoly, right? They are a monopoly. They are the only supplier of these EUV machines in these world. These machines that cost, or tools, I should call them, that cost 400 million. And I think it's a paradox because they're not like a Peter Thiel monopoly type. Yeah, they're a monopoly with consent. Yeah. And I would say that it's not a kind of, kumbaya, all hugs and kisses monopoly. And it's not a consent that it's around morality. It's actually a practical monopoly. The customers consent because there's no substitute at the leading edge at this point for EUV technology and ASML's role. And the cost of fragmentation is failure. And the suppliers consent to be orchestrated by ASML because ASML coordinates demands and has a very clear roadmap. And a single firm's dominance would starve the ecosystem of talent. And again, I think ASML consents, and Martti, I'd be interested in your take on this. They consent not to price gouge, right? Because they don't want the customers to fund alternatives. This isn't an NVIDIA conversation. And if they strangled their own suppliers, and again, in these machines where there's 200,000 components, 80% of which are created by suppliers, 20% are created by ASML, they believe that that would kind of kill the village. And if they break trust, it breaks the system. So at the moment, I see ASML as, yes, a monopoly, but a monopoly with consent.
I think you're absolutely right. I'd like to compare that once again to the government customers in the domain of national security. The fundamental glue in the relationship is trust, predictability, and accountability. I mean, you can't price gouge your customers if you want to have a long-term fruitful relationship. And of course, I mean, if you want to optimize your short-term profits, you can increase your prices, but it is more valuable for you to have a long-term relationship where your customer is also committed to you. And I would not underestimate the importance of that to your employees. The skills and capabilities and the motivation of your scientists and your employees in various stages is in the core.
Mm-hmm.
You cannot replace that. Like what we know from TSMC's story about their Arizona plant in 2024. They booked north of $400 million loss because they were not able to get the new fab functional. Even if they are using the same ASML machines, they are using the same processes that they use in Taiwan, everything, they are not able to get that running. And it's really up to having the skills and the motivation with the people. There's an interesting story written by a professor from IMD, Howard Yu, about that story. He published that in early August. Wonderful reading, and Howard is really able to put that story together. So what I'm saying is that one of the core elements of people being motivated to this mission is that they feel that they are serving some higher motive and objective, and treating your customers with respect and treating your partners and suppliers with respect. It's what these employees, these scientists, these experts, they want to live in an organization that does that. They would not accept price gouging or greed or obnoxiousness toward the peers that you are working with. And it's the same thing that many companies who are working in national security domain with government customers are feeling the same. It's the values of the organization are extremely important for their long-term commitment. And that's important. And why that is important? Because there's only a limited amount of customers that you have for this level of lithography machines that today cost north of 350 million euros each. I mean, they are 400 million a piece, the latest lithography machines. There's not a huge amount of customers for that kind of equipment.
Joe Public
And you don't want to upset these. I mean, if you are a snake oil salesman, you can always find somebody else you can then fool. But when you are selling this kind of investment goods, the clientele is small and the bad news spreads fast. And then how you behave as a partner, as an entity, as an organization, as an individual in this village is equally important. Like in the old days, how the blacksmith is working in the village he lives, it meant everything.
Absolutely. And again, I think we've painted hopefully a picture. ASML has a monopoly on the technology, but it does it with the consent of the village, right? If it starts lording powers over everybody, its reign comes to a crashing end, and the village is very much threatened. And again, Martin is that honest blacksmith, right?
Mm-hmm.
So basically, when he says that here's what's broken, here's why it's broken, here's what we've learned, here's what the next generation will do. It's not storytelling. It's very much operational trust. And you can't do that, you can't suddenly say, let's work on this together. I'm in your firm at 2 a.m. By the way, I want 80% margin. I want to price gouge you over the next 2 quarters.
Mm-hmm.
Do both, right? That doesn't work. Or if you do that, it's a very short-term reign.
Absolutely. And what's happening here is that ASML is not creating a technology. They are creating, but in addition to that, they are creating a social contract around the technology. And of course, our protagonist Martin is the key author of that contract. And when we say that it takes a village, it doesn't diminish the hero's journey. It defines it. The hero's journey is not slaying a dragon alone. It's keeping the village aligned while the dragon keeps changing form.
Oh, I love that. Okay, so let's bring Act 4 towards the end. So effectively, just to be clear, the industry has voted via IPRS through the roadmap of EUV. The industry has coughed up and paid for the co-investment and equity alignment in ASML. ASML has basically said, if we bring back the magic sword, we bring back the magic sword on behalf of the village, and we will fight the slaying dragon and keep it good, into Act 5, right? And again, I think where Act 5 starts is where most people on the internet start with ASML, is the fact that effectively it's a company that nobody ever heard of, yet it's now the most valuable / strategically choke point in Europe. So Act 5, we have the pandemic, we have AI, and the moment that ASML goes from invisible villager to being very obvious on the European and the global scene. Up until 2020, most people went around about their lives without thinking a lot about the semiconductor industry. You probably thought about as much about the semiconductor industry as you thought about the Roman Empire. So not very often in most people's day-to-day lives. Engineers know it, executives know it, and a few governments know it. But then the pandemic hits, and suddenly the entire world discovers that this industry that is kind of quietly in the background producing those chips suddenly stops working.
Yeah. And then we come to the brutal realization that the modern society, the whole civilization where we are, runs on chips. And this is not a metaphorical statement. This is a literal statement. Our cars stop shipping, our cars stop working, factories will shut down, medical devices are delayed. consumer electronics vanish from shelves if the chips supply chain is disturbed. And all of a sudden, the governments start asking a question they haven't asked actually before. Where do these chips actually come from? Who is the supplier? What is the alternative if the source number one dries up? What is the next source? And then all of a sudden we come to realize that, okay, there are not too many supply chains for these.
Absolutely. And the pandemic semiconductor shortage isn't, just to be clear, caused by one thing. It really is a cascade. There is those lockdown demand spikes. There are supply chain freezes. The fabs can't pivot quickly. These are big companies, big systems running high production manufacturing. The lead time stretch to years. And what becomes painfully obvious is you cannot surge chip supply quickly. You can't spin up a leading edge fab in America just because the president says that they want one, right?
Yeah.
It doesn't work like that. Nor in the same way can you spin up a vaccine factory just because we want one.
Yeah, and I mean the other thing is that when the hardware is something that you cannot buy from the hardware store. I mean, for years we've lived in a world where we feel that it's the finance, it's the software, it's software as a service that are the most compelling areas of engineering and business where you want to be in. But the real world is still working with hardware, and when you go to the hardware of building semiconductors, the policymakers, the business leaders, everybody comes familiar with the brutal lesson. Semiconductor manufacturing is not elastic. It is capital intensive, it's path dependent, and it's constrained by a handful of tools that cannot be substituted. And if you ask what tools, you end up in one place, which is in the southern part of the Netherlands.
Not where anyone expected to end up. But again, it's so funny when you tell ASML stories like we have. It's almost the only place in the world that this could happen, right? Where this direct customer-obsessed culture and an engineering DNA all comes together on the back of a company that pioneered light bulbs from the 80s. And this is the moment where ASML moves from important supplier and the biggest tech company you've never heard of to global choke point. And every serious conversation about increasing chip capacity runs into the same reality. If you want advanced chips, you need EUV. And if you need EUV, you need ASML. And there is no workaround, and there is no alternative supply. There is literally this 4-letter acronym, which doesn't actually mean an acronym anymore. It's just the name and the brand of the company. It just stops there.
Yeah. And I mean, this is not an ideology. This is physics. You can subsidize, you can fund fabs and all kinds of organizations. You can try to train engineers, but there is not a school where all the engineers will become fully qualified. I mean, there's a years of practical work that these people need in order to reach the level of competence that is needed. You can build foundries like what TSMC is currently doing in Arizona and Samsung is doing in Texas. But still, you cannot conjure EUV or some of the other critical tools here out of thin air. They will take years to develop. Each one pulls from hundreds of specialized suppliers, and each one is effectively handcrafted at industrial scale because of the physical challenges involved with this technology.
Yeah, and I think this is where one of ASML's most misunderstood strengths becomes visible. If you spend any time looking at this company, you hear craftsmanship more than any other word. And when people think about craftsmanship, they think low volume. But I think the trick that ASML has pulled off is ASML's craftsmanship operates in a high volume manufacturing scale world. Every advanced chip, which is most of them in your smartphone, your computer, your car, that contains logic, memory, and powers AI, that passes through ASML machines. Right? You know, these machines are huge, highly complicated, but also it's high volume manufacturing. And that means that effectively it's tens of thousands of wafers per month. It's nanometer precision. and its uptime targets up all the time, every single day of the year, no downtime, right? That's the target. And this is not innovation theater. This is precision endurance. And
Yeah.
it really takes a craftsmanship type approach.
Yeah, and I mean, even with the danger of repeating myself, I want to say it again. This is co-creation, co-development, co-sustainment with your partners, with your customers, with your suppliers, and also with the academia, because yet another acronym that I want to throw into the soup is IMEC, which is the Inter-University Microelectronics Center in Belgium, that is exactly like TSMC or Samsung. They are developing the yet next generation of microchip technologies together with the rest of the village. So there are more untold stories in this specific village where we are definitely in the bleeding edge.
Correct. There is more to come. There is come. And I feel that we're kind of, almost walking around the village, talking to and finding out the character of the Zeiss villager and the ASML villager, et cetera, as we go. But let's introduce one more character that's joined the village relatively recently. You can put him in a cool leather jacket. Let's talk about
Okay.
Let's talk about NVIDIA. So again, let's talk about, and again, maybe your analogy with the blacksmith was spot on. This is a village of hyper specialists, right? You got Morris Chang in the corner. He is the blacksmith. He is basically, producing every single one of those horseshoes that the village is.
Mm-hmm.
And then Jensen, well, like NVIDIA, they don't even make chips.
Yeah, definitely. He doesn't make any of these, but he and his team is the one who designs, and this is the embodiment of a fabless chip house, which is essentially what Morris Chang with TSMC was enabling. So NVIDIA definitely being a great example of that, designing extraordinarily complex chips optimized for parallel computation. Originally, they were for graphics, like many of us have used the NVIDIA graphics cards in the PCs that, of course, we all built ourselves when it made a lot of sense. But NVIDIA's business works only if TSMC can manufacture those designs at advanced nodes with high yield at humongous scale, which brings us back to ASML.
Yeah. So we have a village of hyper specialists. We have the world's most valuable AI company, NVIDIA, today, or the world's most valuable company, X trillion market cap, relies on a Taiwanese foundry, TSMC, using Dutch tools, ASML, built with European optics from Zeiss, constrained by physics, discovered decades ago. So this isn't globalization as theory. Again, this is why chips are really hard. This is globalization as a single fragile system. And I think, again, AI, which is the moment that we're living in now, AI hits its inflection point. And this is what Jensen bets the company on. Again, moves from gaming to AI. It's not as a research curiosity. In the same way that Zeiss's microscopes were not about research curiosity, it was about unlocking the hidden world. Here, it's an economic force. Large language models, training clusters, inference at scale, and suddenly compute demand is nowhere near linear. Jevons paradox appears, and it's exponential.
And I mean, AI doesn't just need chips, it needs the best chips, which means leading edge logic, extreme transistor density, advanced nodes only possible with EUV, and one additional thing. I mean, why are all these things so important? It goes down to the basic requirement of electrical power. One of the advantages that you get with all these latest chip technologies is that the power consumed per compute is getting lower. And one of the critical elements when we talk about AI is that the actual total power consumed would be totally outrageously beyond our capabilities unless all these latest chip building technologies were into use. So we get to the point that once again only the EUV is the technology that we currently are able to use to design these and build these chips. So the AI race collapses the entire semiconductor value chain onto its narrowest point.
And I do look going back, it's easy to look at ASML today, 400 billion market cap, et cetera, world's most valuable company. And then only half an hour ago, we're talking about this struggling startup having multiple near-death experiences that the customers kind of like, who? ASML what? Never heard of you, et cetera, et cetera. It's how quickly this kind of overnight success from 1984, a few decades in the making, but it's only really in the last decade, the last 10 years, that they've kind of become a hyper-specialist villager, an industry champion. So again, I think the global reality, and when I read this, Martti, this really struck me, is China spends more on semiconductor imports than on oil.
Mm-hmm. Here.
Now, now that's partly because China has dramatically increased its solar usage, 7x, nuclear, et cetera. But again, it actually spends more on chips than oil. Okay.
Mm-hmm.
That's not a slogan. I think that's a structural fact because chips are now economic inputs. They're military assets and they're political leverage. And the world changed.
Oh, yes. And there's the uncomfortable truth is that you can't become a leading edge semiconductor power without EUV. You can't get EUV without ASML, as far as we understand currently, which means that export controls are no longer abstract policy tools. I mean, a lot of this stuff, for example, in the United States, it was not even last year, the year before, when the stuff produced by ASML became subject to export controls. We had the GAFET, the gate-all-around field effect transistor technology that specifically was included under export controls, which essentially represents power electronics today, the latest leading-edge semiconductor technologies of the future. So all this stuff is under export controls today. The AI chips, training Chinese AI models, all under export controls today. So export controls that we used to treat with military technologies definitely are not that today. Anything that is essentially in the leading edge of high technology is very highly likely to become subject to export controls. And this is very practical things when we think about the polarizing, the global politics that we are all witnessing today. These are parts of these trade and the global superpower competition tools.
Yes. And again, because we want our episodes to be as relevant as possible 5 years' time, it's difficult to look at what's happening today in that kind of short-term or long-term consequence. I think about ASML as they want to supply their tools to everybody. They want to be at the bleeding edge. Everybody previously has also included China, right? China is a large part of their customer base, and at some points has been 25 or even 33% of their customer base.
Indeed.
Recent political events have meant that they can't sell their leading tools to China. But you won't go on the internet without finding 500 versions of China has copied ASL machines. It's all over. China has an EUV machine of its own type videos. Now, again, it's very difficult to look at whether there's any substance in those. All I would say is what ASML does is insanely hard, right? And just copying a machine is also insanely hard. And again, remember, these aren't truly machines, they're tools. But I want to move into a slightly different direction, something that we talked about earlier. 1988, ASML went public. Yeah, public company with shareholders. Yeah. But I would argue, Martti, that ASML has never behaved like a public company, right? One, they went public when they had basically no money, which is not normal for public companies. They've always acted on behalf of their customers and on behalf of the village and not on behalf of shareholder value. And again, I think it's a really unusual. You listen to any of their quarterly earnings like we did. Yes, they talk about number of machine ships. Yes, they talk about margins. Yes, they talk about quarterly earnings. But it's always within the context of the village. It's within the context of effectively this semiconductor industry is very price constrained. And we only act within the social contract that the village has created.
Yeah. Well, I've many times in my career, I've heard the customer quoting the Finnish legislation on incorporated companies that begins with the statement that the purpose of a company is to bring profits for the shareholders. But even if that is true and it is written in the law, it doesn't dictate how much profit and with which schedule the company is aspiring for. Which means that even if ASML is a publicly listed company, it doesn't mean that all the owners are the same. The specific set of shareholders that ASML has must have accepted the vision, mission, and values of ASML. And those shareholders who want to have more aggressive behavior from the management and from the leadership of the company, they probably invest their money elsewhere. And those shareholders who value this specific way of managing your company and contributing to the well-being of our civilized society, they remain shareholders. And the fact that the market cap has increased the way how it has for the ASML, I think they have found their set of shareholders who are happy to be part of the extended village.
And obviously, it does feel like we're creating a category leaders universe at this point. But obviously, one of their largest shareholders is Bailey Gifford, who
Here.
we know invests in category leading companies for the long term and hardly ever sells. So again, I think now we've kind of revealed the village of ASML. I want you to go away, listener, with a very clear impression. And this was one of my big insights from the read that ASML builds these super complicated, super expensive machines, yes, but 80% of the EUV components in these machines comes from Europe. Percent. Yeah. So yes, ASML is a Dutch company. Yes, they're the most valuable company in Europe. But 80% of the components that go into this machine, many a single source, Zeiss is the most famous, but far from the only one, they come from European businesses. And I think that is a great credit to Europe.
Oh, absolutely. And here's the irony. For decades, Europe has been criticized for being slow, being fragmented, lacking tech champions, and in this domain where patience, tolerance, precision matter most, Europe quietly built the foundation of the digital age. And I think one of the lessons that I'm at least learning from this story is that fabulous technological capabilities, and we've done so many great innovations. It's really the question is that how do we further develop those for becoming the category leading companies? I mean, we have the capabilities, but we haven't been quite as successful in commercializing them and scaling them to the scale that they are world leading, like ASML as an example shows us can be done.
Yeah. And again, I love the fact that ASML didn't want to be in the spotlight, right? Really. Like, yeah, they did not want to be the most famous tech company in Europe. They wanted to do the impossible mission on behalf of the semiconductor global village. They wanted to play their role, and because they played their role well, they have been rewarded, but they keep their rewards within the context of the village. I think
And you know why? And you know why that is? ASML has been run like an engineering company.
yeah, absolutely.
Their search of excellence has been based on competence, merit, a solid proof, actions, rather than trying to up your game by investing into marketing, PR, and let's say the flashy appearance. I mean, they are in a way an old-fashioned company, thinking that okay, our performance is the only PR that we eventually need, and that's why we haven't heard about them. And we have enough companies in the world who overplay their hand, who hire the best PR agencies of building a company image and then failing to meet the promise. This is the antithesis of that kind of thing. This is the traditional engineering logic where you just try to be the best in the world. And there is still room for that kind of philosophy in companies because, once again, I'm getting back to my favorite subject, the national security domain. Those are the places where I mean, You can talk the talk, but can you walk the walk?
Okay, so I want to kind of go back to that topic that I raised earlier, which is, could EUV, this pioneering bleeding edge technology, could an American villager, not a Dutch villager with a funny accent, could an American villager have stepped forward? Wind the clock back, Marty. What do you think? An American villager, could they have stepped forward? Could they have gone on the suicide mission? Would Hollywood have won this quest?
Well, I mean, this is of course impossible to say, but let's put it this way: if we think about the dominating narrative of running companies in United States, there are many companies that are run by fast and quick and maximum shareholder value in the short term, and in that environment, this would not have survived, just because the expectations of the shareholders would have been in clash with the long-term customer value. However, having said that, there's in Omaha there has been a village head, Warren Buffett and Berkshire Hathaway. If they had been the heads of the specific village, that probably could have been done. But what is the likelihood of that happening? I don't know. But it's, I mean, even United States is not a one uniform color. There are patient owners, and it's so much dependent on whether you are able to find the shareholders that absolutely share your values and want to be part of the village. And it is clear that we've had probably more of those shareholders in Europe than on average we see in United States. But even United States has its patient village chiefs.
Yeah, again, huge fan of obviously Berkshire Hathaway, Charlie Munger in particular. And again, I think they're probably one of the few that could have pulled off. Obviously, they self-confessed didn't do tech, or certainly passed up. I know they have some tech holdings, but
I mean, they've had a few.
Apple particularly.
But
again, I think
BYD,
of course, well. yeah, much more recently. Now, again, so I weigh in on the issue here that ASML wasn't, the Dutch villager basically got the job because they were neutral enough and battle tested enough to take the job, kind of mad enough to take the job. And I'm not saying Americans aren't mad. A number of them clearly are. But I think it was also the fact that they had that kind of flag of convenience and they had the attitude, and that's what gave them the thing. I'm not sure it could have been done in America. But anyway, let's move into our analysis section. A new section on the podcast. Martti and I really wanted to kind of step back from the story of the company, which is what we focused on in the first few episodes, and really look at how are we going to judge this company. We're using Jim Collins' principles, not as philosophy, but as decision tools. If you're not familiar with Jim Collins' work, I strongly recommend it. Good to Great, Built to Last, etc. are exceptional studies of businesses and entertaining books in their own right. And Jim Collins has spent a lifetime distilling the principles of greatness in companies, what makes some companies great and some companies merely good over the long term. So for each principle, we'll debate it, and then one of us will call it yes or no. Does this principle apply to ASML and their monopoly? And particularly, we're trying to think about, where is ASML also weak? Could ASML go from great to being merely good? So principle number one for Jim Collins is about leadership, and specifically a particular type of leadership called level 5, where you have quiet, disciplined, intuition first leaders. So they think more on behalf of the organization than they think about their own bank balance, their own persona, everything else. So we have to address the moment that we're in. Martin van der Brink, Marty, I would say, is a level 5 leader, has been a level 5 leader. Almost, as soon as he was made CTO after he joined the company 2 years in. But ASML's now over 40 years old, and Martin has retired. He's still an advisor to the firm as we record this episode. So I would say that Martin was a level 5 leader. The question for me is, is there a level 5 leader left now that he's stepping down?
I mean, that's That's of course tough because the uncomfortable truth is that Martin was not just a leader, he was a trust anchor that was able to convince the customers when the EUV schedule slipped. He was able to convince the customers that, trust me, I know what I'm doing. So there's clearly a risk there. We of course know that, for example, Apple, who was in an existential challenge when Steve Jobs passed, they were able to find next generation of a leadership that was able to continue the success, and the company has grown tremendously. So it can be done, but there's clearly a potential risk point.
Yeah. Okay, agreed. I think Jim Collins' whole point on level 5 leaders is they build institutions that outlast them. And it's difficult to judge ASML today because Martin's just leaving.
Mm.
But here's my call. This is my prediction. So we can look at the podcast in the future and see if I was right. My verdict is yes, they have level 5 leadership. ASML has really institutionalized humility, customer proximity, and technical honesty in what they do. And I think in the next 5 to 10 years, we will continue to see level 5 leaders within this company.
Well, at least we all hope for that, because we definitely need companies like that in Europe.
Okay, so principle 1, level 5 leadership, we're going yes. Principle 2, first who, then what? So there is that question, is ASML talent deep or hero dependent? So the first who, then what is really that question of get the right people on the bus and then decide effectively where the bus is going, right? And the people stay on the bus. I join this podcast because Martti's on this podcast. I work with him because I want to work with him. If we decide we're going to go in a different direction, that doesn't matter to me too much because I like him. And I think that first who, then what, I think is a very important principle that comes out through Jim Collins' research. Martti, where are you on this one?
Well, I mean, if there is one thing of all these principles that I have the highest trust, is that ASML has been built with the deep engineering benches, long internal apprenticeships, distributed expertise across fabs, suppliers, customers, the partners in the production. Everything has been based on the highest level of skill and capability and motivation. So at least if the past performance is anything to say, they are definitely a people-oriented and people-respecting organization. This is not just a lab, a genius lab. It's an industrial organism that is well beyond the arithmetic sum of the individuals.
Agreed. And again, I'm in two minds on this one. I really am, because I see that first generation, those retiring now, as very much being, we got on the bus, ironically, because Philips pushed us out. But very quickly, you got a bunch of people that really wanted to take on this ridiculously hard challenge. And they did it because the other people were there taking on a ridiculously hard challenge with them. So I get that, right? So I think that founding generation, if we call them that, they're definitely first who. And then we decided on the technology. EUV didn't happen in 1984. Well, it did, but no one believed it.
Yeah, exactly.
But effectively, they went on the journey together, and it was the journey that shaped them. Now, the question will come, will effectively the challenges that ASML faces over this next 10 years, which are still insanely complicated to push the frontier, will that continue to shape the generation of engineers and leaders in the business today? Right? Because the challenge is so hard, will it continue to be the culture and create the culture of the company and enforce company culture? Or does it become fat cats on Wall Street just milking the profits and not creating a generation?
Well, I can guarantee you, if bankers, lawyers, and accountants take over the company, it will be killed in no time.
Okay, so at this particular point, I think on first who, then what, just because the sheer challenge that they continue to take on, I think they are in a very good place in terms of effectively that first who, then what principle. Martti's caveat considered, which is if we start to see a lot of bankers and lawyers fronting ASML quarterly earnings, then maybe not investment advice, but you want to consider your position.
Exactly.
So principle 3, the genius of the and. This is one of my favorite Jim Collins's principles, which is ASML has this, genius of the and really refers to its monopoly and restraint, power and consent, profit and ecosystem health. It's the ability to have two seemingly opposing things at the same time. Profits and growth for the long term. Can you have both short term and long term? So, Martti, where do you think ASML is on the genius of the and?
Well, I mean, so far, they could extract more value, but they don't. They
Okay.
could squeeze suppliers. They don't. They behave like infrastructure, not like a conqueror. My only question is that even when we are currently producing the chips with the current technology using EUV, Moore's law, if we want to follow that, will see the next step change one of these days in the future. And then when going gets tough, how do you survive the next rapids that are full of devious rocks that are trying to topple you over? And that's when we know. Today, I mean, EUV in production scale is not that old. I mean, what is it? I mean, 6-7 years old in a real scale. So we are in the smooth part of that generation. But when yet another 5 years go, then we know when going gets tough how they will survive. But currently they are treading lightly. Currently they appear to be doing the right thing. So I'm definitely saying yes here.
Agreed. I think, again, the danger that the Jim Collins framework would flag is that this principle doesn't fail suddenly, the genius of the and. It actually fails quietly and under pressure. This is the one where activist investors, geopolitical demands, whatever they will be next week, national security framing, that's difficult. That, shareholder quarterly returns, etc. I think when you look at ASML, you should judge their behavior, not their hypotheticals. So far, I'm with Martti on this one. They very much have been able to hold true on principle 3, the genius of the and. I think this one's actually slightly easier. Principle 4 for Jim Collins is confront the brutal facts. So I think confront the brutal facts, which is regardless of your situation, make sure that the reality of the world is real, not your internal narrative of a charismatic CEO or market fantasy. Yeah. So I think when we look at the facts that ASML faces, they're pretty brutal. You have the geopolitics. You have China, you have potential alternative technologies, you have single source supplier fragility, and you also have hero succession. I can see how ASML has basically confronted the brutal facts of its cash position and its technology position and its respectability within the village throughout its life. But it now faces a different set of facts.
Yeah, I mean, the leadership is clearly talking about this. They are not living in denial. But here is the point that if in my assessment, if there's a potential crack in this success story, it could be here. Because when we talk about geopolitics, when we talk about China and its humongous investment into these technologies, the potential alternative technologies that may need to be taken into use in order to reach the next level of capability, supplier fragility. I mean, there are many, many things that we don't have. We don't know about the risk assessment they've done. We don't know about the risk mitigation plans that they have in place. So all I can say here is that these are potentially existential risks. And I don't think that any company can totally avoid these risks or mitigate them 100%. So the unpredictability, including the infamous black swan, may all of a sudden come in here. So just for principle, I would say that this is the gray area. I'm even bold enough to say that no business leader can ever take these elements too lightly. So just for sake of sparring ASML to take this seriously, I want to say that this is not an area that they control 100%.
Yeah, I think this is a one that they'll find the hardest going forward. When we look at the set of principles, this is kind of the yes, but it's a weak yes. It's really difficult considering they've gone from single point of failure. They've gone from unknown to single point of failure in the world pretty much overnight.
Yeah. And I mean, this is a nice place to feel humble.
Yeah.
Because these are the things that are not in your control. If you think that you have these under control, then you don't know what you're talking about. So this is an area where you have to have a clear management focus and the ability to go through alternative scenarios and then be able to react, because sooner or later the soup will hit the fan.
Agreed. Oh, principle number 5, what Jim Collins refers to as the hedgehog concept. And this comes from Isaiah Berlin's famous essay around hedgehog and the fox. And really the concept here, for people who are not familiar with it, is that you're looking for effectively, imagine a Venn diagram of 3 overlapping circles. So what are you passionate at? What are you passionate about is in one circle. You know, what can you be the best in the world at is in another circle. And then the third circle is what drives your economic engine. And where those 3 combine, passion, best in the world, economic engine, Venn diagram circle, the overlap, that's your hedgehog concept. You have to have an insight that what you are passionate about, that you can become the world at. Like, I think ASML is a hedgehog business. I think this is an easy slam dunk yes. Yeah, because they are clearly passionate about unlocking the capability for they're not passionate about EUV per se, right? They are passionate about unlocking the capability for their customers to basically deliver capability to their customers.
Indeed.
Where they stay.
Yeah, well, I mean, they haven't drifted away from the core. So yes, I think they are focused as far as I can see.
They are a very funny Dutch hedgehog. Now, principle 6, the flywheel. So I think this is where we should analyze, is the momentum still compounding? You can still have a super successful business, but the flywheel is slowing. Flywheels don't have to come to a grinding halt. They can just slow imperceptibly over time. And ultimately, you do a few tweaky optimizations, but is the underlying flywheel slowing for ASML? That's the question.
And I don't think it is. I mean, it's of course there's a lot of research that is not in the public domain. So I mean, we cannot know everything that happens. But I think the core, when we think about the European capability, and just as one of the players that I mentioned earlier, the IMEC, the Inter-University Microelectronics Center, there's a roadmap. There are plans that go well into the late 30s of planning the next generation capability that will then meet the customer expectations. I think it is there. So there is clearly, the flywheel is there, the momentum is there. However, having said all that, the risk is that something unexpected, an event coming from third parties, the event that will all of a sudden, like the pandemic, all of a sudden break our well-crafted system. I mean, these step changes may happen. Something unexpected has happened. Something unexpected can happen again. But when we talk about the principle number 6, the flywheel, yes, the flywheel is there.
Yeah, I think this is where their install base, their service data, and their customer attention, love, proximity, whatever you want to call it, that reinforces, I think, their flywheel. And ironically, AI accelerates it. It goes faster. Okay, it's always 7, magic 7. Last principle is preserve the core, stimulate progress. Now, ASML is the youngest company that we've had on Category Leaders. You know, Bailey Gifford's 1907, Airbus 1974, Zeiss 1846, right? These companies have to endure and be great over a long time to be a true category leader. That's our bar. We keep it high. So ASML is currently at its 40-year, just past its 40-year anniversary. Can ASML preserve its core, and that's its DNA, its values of its company, its culture, everything, and still feel restless? Can it still chase the frontier?
Yeah, well, of course, if we focus on the technology roadmaps and all that stuff, I mean, there are of course the great elements, but then there's another risk that I want to mention here. If we think, what is the level of higher education that we have in Europe? What are the skills and capabilities of the young people who go to the STEM fields when they graduate from universities? Where are they passionate? Where the passion is? Are we treating the deep expertise in the society with the respect that it deserves? I mean, in order to be a world-class physicist, it takes years and years of focused studying. There are some forces in our society some forces that are not respecting expertise. They are not respecting deep understanding and deep knowledge. We are much more superficial as a society, and we appreciate other things, much more superficial things. Things like that everybody's opinion matters. Things are opinions. We are expecting that people are doing their own research and taking stands on very complex subjects like the climate change. I mean, that's not going to work. And the only way how ASML and other high technology companies will thrive and survive in the long term is that we as a society take science, technology, engineering very seriously, and we appreciate people, and we are able to reward the people accordingly for their contribution. And this is so critical. I mean, people need to feel, young people who are making a choice of their future careers, they need to feel that my investment into science, technology, and engineering skills and capabilities is respected by my peers, and it is properly rewarded so that I can have a satisfying life for me, my family, for my loved ones. And I'm a bit afraid that our values as societies are not necessarily fully supporting. So yes, absolutely, the technology roadmap is impressive. Do we have in 5 and 10 years enough people who want to excel with these disciplines?
Good question. I think on this one, ASML's trump card on preserve the core, stimulate progress is ironically the harder is easier in my book.
Mm.
The face of technological challenges that they need to overcome just to stay in the game actually means that they have to keep stimulating stimulate their core. They have to keep changing. They have to keep reinventing themselves, because otherwise they will die and they will be copied not quickly, but very quickly over time. So I think on this one, I hear you. I think that this is again a weaker yes, because ASML is young. It's 40 years old, right? It's the founding generation are now moving out of the company, even if they're into interim advisory roles. So in terms of the analysis section, if we look back at the Jim Collins principles, just keeping notes, I think we've got so we have level 5 leadership, yes, principle 1, but there is that question of how does succession play out post Martin and others. First 2, then what? Yes, again. Genius of the and, yes, I think that's one of their core strengths. Brutal facts, yes, but a weak yes.
Well, I'd say maybe.
Maybe. Okay.
I mean, we need to be humble. I mean,
yeah.
there are risks that are beyond our control, and we will be in a reactive mode. So I would not beat my drum on that one.
Okay, I think the one that you would beat the drum on, I would, is Hedgehog.
Oh, absolutely.
They are a hedgehog business, no question.
Oh, yes.
And the flywheel with AI particularly is going faster, not slower. Preserve the core, we just talked through. Let's see where it goes. So by Jim Collins' standards, and again, I would say ASML is a durable, institutionally strong company and not a temporary winner. They are a consent monopolist, not a monopolist through control. But if you go on the internet today, January 2026, you will see that ASML loses its monopoly every 5 seconds, right? Because its machines are complicated, but China has copied them. So where do we stand on effectively the China catches up? Are they 10 years behind, 10 minutes behind, or have they already caught up?
I mean, that's a tough call, and while we were doing our research on this matter, I was listening to many very, very good speakers on this matter. I mean, technically, it's impossible for us to say. I believe if we remember, once again, getting back to our protagonist, Hiroki Noshita, who in 1986 was able to with his research team, was able to put together the first proof of concept of
Yep.
having lithography with X-rays. I mean, it took many, many years for that to become a production standard. If I would have to guess today, my guess is that China is not there. They are not breathing. They are not right there. It will take years for them to reach ASML, but at the same time, you can do a whole lot with the previous generation technologies. I mean, the DUV machines that have been delivered by ASML to China, they can be used in ways where you can where you actually increase the performance of the chip, and you are using the third dimension rather than focusing on the two-dimensional structure of the chip. You are building layers and layers and layers and layers. So there are ways. And what I would say is that rather than and of course, I mean, this is an opinion. This is not a scientific truth that I'm saying. Rather than being too much worried about them catching up with EUV, exactly like ASML reached the competition when there was the disruption of the technology, I would be much more worried about China actually making a quantum leap when the next generation capability is there, because China has the capability. They have brilliant scientists. They have endless amounts of money for the time being, unless a black swan is swimming to their corner. And therefore, we should never underestimate the ability for them to come up with the next generation solution. So I wouldn't be worried about China in the next few months or even a few years, but in 5 years, a lot of things can happen.
Yeah, and again, I play this one forward in my own mind. So China / some Silicon Valley startup funded by some VC, etc., invents the next technology paradigm and jumps ahead of ASML. So what actually changes for ASML? Well, if China stopped importing chips and basically built its own chips, ASML's not out of business, right? There's actually a massive global shortage of chips. So China's importing as many chips as it does, and pays less to US and other suppliers, TSMC, etc. The world doesn't stop moving forward.
No. Of course not.
Kind of like, yeah. So I'm kind of, that's less of an existential risk for me. Again, I also believe that, again, and there's a number in the market at the moment, and this will have changed by the time most people listen to this episode. So effectively, you've got the X-Lite in Silicon Valley and Substrate, who've recently taken in large amounts of venture capital. They've basically focused on a new technology around EUV or a new way of basically achieving the same capability. Too early to say whether they're a serious threat to ASML. But again, I would position it differently. Just because someone else is prepared to come forward and basically bring a capability to this hyper specialist village, maybe that threatens, say, ASML's monopoly. But ASML is not about its monopoly. It never has.
I agree.
That's like a framing that we're placing on this company. Sorry, I think is placed on this company. But actually, ASML doesn't win because it owns the technology. It wins because of its coordination, its consent, and its compounding trust, and the fact that it's chasing the horizon.
Yeah, and I mean, now we are here, the let's say the hangarounds of this microelectronics village, and we wanna visit and stay there as long as we can. What I'd like to say here is that competition is always good.
Yeah.
A non-competition leads into complacency and laziness and lack of innovation. It would be in the interest of ASML to see genuine competition, because that would then motivate them to up their game once again. It's very difficult to be the first of the pack.
Agreed. Okay, I think we need to wrap this up. We have arrived at the quintessence. Like, what do we feel is the hidden truth that it's been in plain sight this whole time? So for me, it's because ASML exists because some problems are too hard for sometimes competition to solve, and that they require coordination. And ASML, on behalf of the village and with the consent of the village, has played that role. That's the takeaway for me.
Yeah. And my key takeaway, I have two takeaways. The first one is that if you are in search of excellence, competence is key. I mean, there's no way of going beyond that. And of course, the fact that I have an engineering degree and I have been working for industry my whole life, it's not a surprise that I'm all in favor of competence and searching excellence through that. But the other thing, which is, I think, a very, very valuable lesson here, is that you can satisfy the shareholder expectations in the short term, and you can do that in the long term. There are different kinds of shareholders in the world. Not everybody's expecting the same way of running your company. And there are customers, there are partners, there are suppliers, and there are employees, your teammates in the organization, that appreciate a long-term partnership, commitment, approach to these questions. And it is wonderful that there are companies who have been able to find also shareholders who appear to value this kind of strategy and this kind of behavior.
Absolutely. Absolutely. Okay, so we're going to draw a line under ASML. We're leaving the Netherlands. It's been a great journey, and we've really, truly enjoyed telling the story with you. So before we wrap, we want to introduce next month's category leader, because ASML is not the only European company that quietly coordinates or controls something quite fundamental. There's another one. And again, most people have never heard of it, but they're actually wearing it on their face.
Yeah, and this
we'll talk about next month.
Yeah, and this company is called Luxottica. The revenues around 27 billion, and it sits somewhere between healthcare, fashion, insurance, retail, which already tells you something strange is ongoing.
And I love the fact that we're going to Italy, not just because I'm sure the weather's better, sorry, Netherlands, but here's the usually surprises people. Luxottica controls somewhere between 70 to 80% of the global, and I'm using these words deliberately, wear value chain, not glasses, eyewear, okay? And it's not just the brands, it's the whole stack.
Yeah, and if you've ever worn Ray-Ban, Oakley, Persol, or if you've ever bought glasses from LensCrafters, Sunglass Hut, if you've ever worn branded lenses like Varilux, you've probably paid the Luxottica tax.
So again, I think that this is a super interesting company. Again, it's a monopoly kind of hidden in plain sight, and regulators know this, but they clearly tolerate it because so far the system works.
Yeah, which makes it very familiar kind of monopoly, exactly like our friends in the Netherlands. You are representing essentially a monopoly, one that doesn't feel too aggressive, one that doesn't feel too technical, the one that hides behind brands people love.
And again, if ASML showed us how Europe controls intelligence for machines, Luxottica may show us how Europe controls visions for humans.
And let's leave it here. It's another story to tell, and we've talked here enough for today. But the real question is how Luxottica got there. If it's weather, if computing moves from phones to faces, then they've already positioned themselves perfectly. And it's interesting when we think about Europe, European countries, European Union, and the collaboration between these nations. There's a lot of room for improvement. But hiding in plain sight, that we have these companies who have actually made the European collaboration and global collaboration as a part of their existence. So collaboration is possible, even if it is sometimes if it looks a bit challenging, to say the least.
Absolutely. And I'm particularly interested to dive into the Luxottica story, because I also want to understand whether we're all going to be using smart glasses or smart eyewear in the future, or are we still going to be glued to our phones? So I think telling Luxottica's story also allows us to project forward in terms of who is going to be the category leader, not just in eyewear, but in that new form function, if it appears on our face rather than our phone.
Yeah, remains to be seen.
Absolutely. Join us next month. Thank you very much for listening to Category Leaders.
Thank you so much.